Good morning, sir. So there are over 100 participants right now connected with us. There are total 104 participants. So, sir, I guess we can start, sir, with your permission.
No, I'm all right. Anytime you want, please get started.
Okay, sir. Okay, sir. So, good morning, dear participants. On behalf of all the participating academies at IIT Guwahati, NIT Patna, MNIT Jaipur, Triple IT DM Jabalpur, IIT Roorkee, and IIT Kanpur, we welcome you all in this day 7 of 2 weeks long joint faculty development program on Internet of Things in smart systems. So today's lecture will be taken by Professor S.K. Sinha sir. So before we begin, we will have a short introductory profile of Professor Sinha sir. Professor Sinha did his BE in Electrical Engineering from Bihar College of Engineering, Patna, in the year 1967, which is now NIT Patna, and ME and PhD in Electrical Engineering from IIC Bangalore in 1978 and 1985, respectively. On completion of his doctoral program, Professor Sinha was offered a faculty position in the Department of Electrical Engineering at IIC Bangalore, where he worked till 1995. He set up a new parallel computing lab in the EE department, and most of his research efforts were directed towards applying the parallel and distributed computing techniques for industrial drive applications. He then moved over to the Center for Electronics Design and Technology, CEDT, at IISc, where he set up an embedded systems laboratory. The lab has now matured into a leading training and development center in the area of embedded computing. He retired from IISc in 2011 and after a few years of preparation set up Lab to Market Innovations Private Limited at IISc. This initiative is seed funded by IISc, which also holds equity in the company. Lab to Market is innovating products and solutions to make railways safer and more efficient. During his tenure at IISc, Sinha sir worked on a number of research development projects sponsored by governmental agencies such as DIT, Indian Railways, National Tuberculosis Institute, DRDO, and BHEL. In addition, many projects have been carried out with funding from multinationals and SMEs such as Motorola, Freescale, Tejas Network, MCML, Impact Solution, etc. With these few words, I would like to welcome and invite Professor Sinha sir on the dais. Over to you, sir.
Thank you very much for your kind words. And I would like to get started with the presentation. Let me share my screen. I hope everybody is able to see my screen.
Yes, sir. The screen is visible, sir.
Okay. So I'm going to talk about our work on making railways legitimate part of Internet of Things, industrial Internet of Things, or what you may like to call Industry 4.0. We are focused totally on that domain at the moment. And as it was mentioned, it's an effort which is supported by Indian Institute of Science. So what I intend to cover in the next 45 minutes or 50 minutes is something about this lab to market concept itself. Why did we set it up, and who are our current partners? And then I would get into some of the work that we have done to make railways safer and more efficient through the Internet of Things efforts. The reason why I thought of having an entity like Lab to Market was my experience of nearly 40 years working with IISc. There I worked in many administrative positions, including chairman of Center for Scientific and Industrial Consultancy. I was also advising the Society for Innovation and Development. And I could understand the gaps. Why, with so much of talent and so many facilities available at IISc, IISc was not able to make a real impact to the industry except in the defense and aerospace application. The contribution of IISc to aerospace in particular has been immense, and also on defense related projects. But when it came to other industries, it was not much to talk about. And I have been, understanding why so. And some of the things that, I mean, there are many other aspects also which I would skip today because I don't have time. But the main reason is that the industry in India particularly, or all over, they need products which can straight away deploy. They simply are looking for something which is a production prototype, not a proof of concept. But in institutions, all institutions, including IISc, basically develop at the most a proof of concept, because their focus is on working towards publications, training of students, basic research, and what comes out are the core technology, something new or some new applications, but they are not targeted to a particular product or a particular industry or particular solution. So though these things, this work done by academics can become a chief ingredient for new products and solution for the industry, it requires a lot of effort to translate, and also that has to be a targeted R&D again, starting from what the academic institutions have done. A very concentrated, targeted R&D has to be done to make a product from the core technology which have been developed at the institutions. And then this requires a lot of investment, which can be very, very risky. And these are the main reasons why the industry generally gets disappointed, particularly railways. I know, since I have been working with the railway domain for past so many years, they are thoroughly disappointed with academic institutions. I have no hesitations in saying that. And these are the basic reasons. It's not that there is, there is any dearth of talent. There is a huge talent, and more importantly, there is a huge infrastructure with the academic institutions and also public funded laboratories, and which private industry or a startup cannot even think of having. So knowing both sides, I was wondering what can be done. And then this idea started emerging in our mind, and I started discussing it with colleagues. And finally, we are here today. I will tell you more about it. So this company has been incubated at IISc basically to bridge this gap, to take up those targeted R&D. This is a technology company. We don't manufacture things. We don't take contracts. We only deliver the products and solutions, but we deliver it end to end. And once it is done, then we take up another challenge. So this is basically to develop new solutions, and we like to engage with academic institutions and other public funded CSIR laboratories to benefit from their talent as well as their facilities. So our strategy is summarized here. We keep in touch with all academic institutions. We keep attending seminars, conferences. We go to their websites. There are a couple of people in my organizations whose sole job is to keep looking at the website of every institution, going to the LinkedIn to see what new they have reported, and what are the new things that has come up from there, which we can use to take to the market. Then comes who will pay for that R&D. So we have to see, we also need to keep in touch with industry where there is a pain which needs to be addressed, and where the new technology which are coming from academic institution could be utilized to address those pain points. And then we approach them and ask them that we can offer this, provided they are willing to invest in that. And if they get convinced, they would invest. Then we collaborate with the institutions. When I say institutions, I mean academic institutions like IIC, IITs, and as well as the public funded CSIR laboratories in particular. Then we set up teams to work with the academics at one end and the industry at the other end, and we develop the solution or the product. And once it is successful, we license it to somebody else. As I said earlier, Lab to Market is a technology company. It's not a manufacturing organization or a contractor. So our connection with IISc is very deep. We are seed funded by IISc, and IISc holds equity in our company. We also, in addition to the equity, we pay 1% royalty on revenue to IISc. For every 100 rupees that we get, 1 rupee goes to IISc. And in return for that, we get access to all their laboratories. We are treated like any other department of IISc. We have to pay for that laboratory facilities, of course, but it cannot be denied to us. If we need it, we have to request them for time, and we use it. Then we also have access the first right on their patents and other IPs of IISc. And then also we engage very heavily with IISc faculty for taking up joint R&D projects. Then the resulting IPs are shared with IISc. Just a few photographs of that. It's a 450 acres of a very green campus in the heart of Bangalore. It can become very colorful during some seasons, which is now. Now, if you walk into IISc, you will find it lovely. It has more than 500 faculty members and about 5,000 students. And interesting thing is that out of these 5,000 students, more than half, at present, more than 2,600 are pursuing PhD. So it is primarily a research institute, and some courses are also carried out. The founding team, one is, of course, myself. I have already been introduced. And the other founder is Mr. Srinivas Rao Ganapa. He's an ex-railway officer, Indian Railway Services person from Signaling Department. But after working for railways for about 12 years, he quit and he became an entrepreneur. And he has a massive background of starting companies from scratch, taking them to a very, very good level. In fact, that is how we had come into contact, because one of his companies had hired me as a consultant to develop an electric interlocking for a unmanned level crossing. So that's how we had come into contact. So we joined hands because I needed somebody from the business development side also. Otherwise, I had no clue how to raise funds, how to approach the market. So he provides that support. And then right from day one, we have taken 4 faculty members on board. We had no money to pay for the consultancy to the faculty, and we approached IISc for another new kind of arrangement that we need their support, but we don't have money to pay them. So we would like to engage them with equity. And it was something new, but IISc agreed. So these 4 gentlemen, Professor KJ Vinay, who is presently the chairman of EC department, Professor Umanand, who is now the chairman of DESE, Department of Electronic Systems Engineering, earlier CEDT, Dr. TV Prabhakar and Mr. Haresh Dagle, both belonging to DESE. So these people have been with us from day one, and they hold equity in our company. We don't pay them money as such, but they would benefit as the company grows. Then we have now signed with many CSIR labs. CSIR NAL, we have an MOU with them, and they are helping us in developing some of the core sensors for us. I will talk to you about it because this is being imported at present, but we are developing in-house. And CSNAL has a unique background in this. They have been using the sensors. I'm talking about an uh, fiber Bragg grating sensor, which is an optical sensor. I will explain that a little later. So NAL has been using it for the last 20 years to monitor the strain on the aircraft wings. So they, fortunately, they agreed to support us, and we have an MOU with them, and they are working with us. The surprise name is of RRCAT at Indore, Rajaramana Center for Advanced Technology. This is actually not a CSIR lab. This is a cost center or a captive unit for DA, Department of Atomic Energy, and they work only for them. But we needed this FPG sensor, and RRCAT being an atomic energy initiative, nobody gives anything. They cannot import key technologies. So they have to develop everything in-house. And it was a huge surprise to me that while everywhere else we are importing FPG sensors, RRCAT not only makes their FPG sensor, they had even to build their own machine to write the FPG sensor, which is a very, very complex process. But they are experts in lasers, and they use their knowledge of physics to make the equipment itself for writing FPG. And when I met the director there, at first he was confused how to support us, but he was very keen to support us, and then they found a way. So we have an MOU with RRCAT. Then CDOT Bangalore, we have engaged with them very heavily. In India now, railways, particularly some metros, are being run by communication-based systems, but it's all imported. Nobody has used CDOT in the railway domain except us. Of course, when they first deployed their systems for us, it didn't work, but we gave them the feedback. They worked very hard, and I am happy to report to you that now we have communication-based train control at one place deployed in Karnataka, and that entire communication equipment has come from CDOT. 1 year it has been working flawlessly. We also have an MOU with another CSIR lab called SCRC in Chennai. This is a structural engineering research center. It's a huge facility for structures, and they are our partners in development of a structural health monitoring systems. So these are the PSU partners. Then apart from IIC, we have signed up with other academic institutions as well. VNIT Nagpur, we don't have a formal arrangement yet, but we have working very closely, and they are very keen to have a unit of lab to market at VNIT. Their students have done wonderful work on some defense related projects, which I am pushing now. Then there is Oxford College of Engineering. From there, a couple of research students are tied up with us. We have an MOU. There is an institution, Sai Vidya Institute of Technology in Bangalore. We have now very deep engagement with them. We have set up 2 labs in that college, and we take student interns from them, paid interns. For the last 2 years, we have been taking. Then we have tied up with a college called KCG College of Technology in Chennai. This college becomes the bridge between us and the SERC in Chennai because they have one expert on FPG. So we have an MOU with this college. And we are in advanced stage of negotiations with Dayanand Sagar College. We are likely to set up a center there for data science and in AI. Our current focus is on railways, as I mentioned, because railways presently majority of the maintenance of the railways are manual. Every piece of rail is a safety hazard. Every wheel is a safety hazard, but everything is manually inspected. And as you can understand, that between 2 inspections, something can go wrong and accidents happen. And it's not just with Indian Railways. It's the same story all over the world. Now we have technology is there to change it, and we are working for it. The problem is that any solution for the railways have to be safety certified. It's very hard thing to do, and it requires massive investment as well as massive, equipment. Thankfully, this lab to market concept is working very well because we are engaging with IISc and other institutions and utilizing their equipment and facility plus manpower. And now the railways are beginning to see the potential in us, so they are investing. So now let me come to some of the core technologies which we have developed for railways already and deployed. The first one I would like to talk about is what we call cyber signaling. We have already granted the patent for this. This is a term which we have coined and trademarked, cyber signaling. This relates to monitoring of the railway sidings. You see, you are all familiar with the passenger traffic. You go to the railway station and a platform where you get into the train. But there is a huge infrastructure which we normally don't see. That is for goods traffic, for cargo. And in India now, railways have taken up a very big way. A dedicated freight corridor is being set up, already running. 2 corridors partially are already running. Trains are running there, and there, the requirements are very different from the mainline passenger line. They need far more flexibility than the signaling systems which are intended for passenger traffic is done. But nobody cares for it. Nobody has done it. As a result, that is all done manually. So we have focused on that, and we have developed a technology especially for monitoring of those sidings, industrial sidings or yards. And we have now developed a completely wireless cloud-based signaling solution. When I say cloud-based, it's not a public cloud because it's a sensitive thing, and we cannot afford it to get hacked. So these are private clouds, and we are using this. Actually, cyber signaling is a system of systems. So we have point machines to move the track. I will show you all that in a moment. And then we have signals for the drivers. Of course, many of these concepts are new for the first time, at least in the country. And we have implemented one system in Jindal Steel Works, which is the largest steel plant in India. It's in near place called Ballari in Karnataka. So this is actually designed, as it is emphasized by italics, for decentralized control, because the passenger traffic, the control is totally centralized. Only the station master from his room has the control over all the signals, all the track. He decides which train will go there. He sets the route, and nobody has even the view of that. Nobody knows which track is free, which track is occupied, which train is where, except the station master. That doesn't work for private sidings or industrial sidings. So we had to make a decentralized control so that more than one person can do it. And that person need not be a stationary in a room. It can be a driver, it can be a pointsman, somebody who is on the move. It should be monitored all the time. And this system that we have developed, it enables the drivers to see the yard. What is the status of the yard? Where is he in the yard? Where are others in the yard? What is the status of the track? Which track is going straight? Which track is taking a deviation? This all has been developed. So this is, I think I have already said all this, so I will skip this. I will just show you the example where we have implemented it. We have done it in Ballari. This vehicle that you see over here in the picture, this is called a torpedo. Basically, it is intended to carry about 400 to 500 metric tons of molten iron. So in the blast furnace, they melt it, and then it is carried in these special purpose vehicles to the steel melting shops, where it is poured out and for further processing. So this is actually a lifeline for the production. They produce more than 200 crores worth of steel per day. and that entirely depends on this movement. So this movement has to happen uh, smoothly without any difficulty for the plant to operate. So this year, and this year totally manual operation earlier. So what we have done is like this. This yard, they gave us one portion about 1 kilometer. There are 3 entry lines and which terminate into 4 pouring platforms. So a train entering from anywhere it has come. Now that driver doesn't know where it has to go because no, he has no idea which platform is free. So he is told on the walkie-talkie to go somewhere. Then he would come to this point. Suppose the train is entering over here and he is directed to go to this place. Then the driver will come, he will stop here and then set this turnout so that this takes him to this direction. Then after coming over here, he will again stop here and make sure that the turnout is such that he can go straight. Then he comes out, stops here, then again changes the track manually, and then he goes straight. So this was the present system. Now we have uh, instrumented the tracks everywhere to know which sections are where. What you see, these DPs are detection points, which are nothing but sensors which do the detection of the train. And we have set up the radio access network with which is supplied to us by CDOT. So it's an entirely wireless system. These are now we have replaced the manual machine with the point machines. And these point machines are operated wirelessly by the driver himself. So this is the kind of handheld device the drivers get. It's a rugged industry grade tablet, which the drivers get. And at any point of time, the driver has a view like this. This red indicates that a torpedo and a train are there. These reds indicate that already there is a torpedo which is pouring that. This section is free. So if this driver wants to go somewhere, he knows that he has to go straight. And so entire yard view is available with anybody, any authorized person. So drivers carry this now in JSW. The way it is operated is like this. This is the point. This is the track setting, and I would like you to take a look at this point. What I am showing you here, the track that moves, and this is the signal which the driver gets. So both these things will change when this little girl operates the point machine. This used to be done by manually through a lever. Now the point machine has been set up. A wireless system has been set up, and I will run this short video. Notice the point how it is moving and signal which is green here. Now the point will move, how it has moved, and then the signal will also change its color to indicate to the driver that point has moved. Okay, so that's it. It can be done simply by anyone, authorized person, by this handheld device. It can be done from within the driver's cabin itself. The drivers don't have to go down to do it, and how they get it is shown by this short video. He selects the point. He has seen in the status of the point in the handheld device itself. He operates it. Now the point is operating, that is indicated on the device. Okay, and when the point has operated, it changes color to indicate that, okay, the point now has changed position. He can go ahead. Okay, so the driver doesn't have to get down now. He can do it right sitting in the cabin, and it saves enormous amount of time for the driver. And remember that he is managing a 20 crore worth of equipment, that locomotive. So every minute saved here matters to the company. Okay, this is again on the move. It shows that how they are operating. There is a lady driver also there, and then they are operating it. So this is the kind of dashboard in which they get, and now that we have the data for everything, we are able to tell them so many things which they didn't have the information, or they had to depend on the drivers to tell them. Now anybody in the management who is authorized to see that, they can have the past history, and they can even play back. Suppose there has been an accident, then the full record is there. They can actually play back the movement of all trains in the yard at any particular time to know what went wrong. So JSW is absolutely delighted to have this system. 2 days ago, last Sunday, the director of DFCC visited them, and he wants to us to replicate this in one of their yards. The routes can be illuminated. The driver doesn't have to come to every point and do it. Since he has the view of the thing, he can set the route for himself and illuminate it. Now the route is locked for him. He can straight away go there. So this was about cyber signaling, which is already implemented and working for nearly 1 year in that. The next one technology that we have done is called axle counter. Now, axle counter is not a new technology, but we have implemented it with the fiber brag rating. That is what is new, and we call it axle counter plus, because conventional axle counter only tells you the count. Our system tells more than that. So we have been granted patent for this already. Basically, the axle counter is needed for signaling purposes. I need to know the driver or the management needs to know which section of the track to free where they can send another train. So what the axle counter does, that you have a section defined by 2 detection points. All the axles entering at detection point 1 are counted, and all the axles exiting from the detection point 2 are counted. If these 2 counts are same, which means that section defined by DP1 and DP2 is free, and the next train can go in. So that is the purpose of the axle counter. It's a very basic system that is needed by every signaling system. So what we have developed is axle counter with a new technology, fiber brag rating. I will tell you about it in a moment. And we have got something extra features, because we are not just telling them that the section is occupied or free. We are also telling them what is there on the section. So little bit about some of you who are working in optical domain, they may know about it, but for the benefit of those who are not into optical domain, and fiber brag rating is basically created on as optical fiber that is used for communication. The same optical fiber shown over here. What you see is the buffer, outer buffer. Inside that there is a coating, then there is a cladding, and inside that there is about 8 to 9 micrometer diameter core is there, which is the actual fiber and which carries the signal. Now when there is no grating, all the light that enters from one end exits at the other end. But these gratings are created through a process which I will show you now. And once these are created, they act like a selective mirror, which reflects a very narrow band of light. So when a grating has been created and the broadband light is sent, most of it exits, but one narrow band of light is reflected back. And that is monitored. So we know the nominal, wavelength which will be reflected, and what is reflected back is monitored. And what is the difference between the two gives us a lot of information about what we are monitoring, as I will explain. So this is what we are working with. This is system. This is about, I would say, been there for about 20 years. IIC researchers have done a lot of work and developed many sensors out of this FPG. From there, we got the know-how, and we have adapted for the first time in India for the railways. And there is only one more company which is taking it to the railways in the world also. So there are very few players in this. Certainly in India, we are the only one. So this is what we are using as a core sensing technology. This video will show you how it is made. The optical fiber is cooled, and then a very intense ultraviolet light through a mask is given to that. Mask is something like the same like you make semiconductor chips, something like that. Same type of mask is made, and that causes the gratings to be done. And once this grating is created, now this acts as a sensor. Basically, it is sensitive to a strain and temperature. So once the grating has come, the and the light enters one particular narrow wavelength, say lambda b, is reflected back. Now, the interesting thing is that if it is strained, suppose it is stretched, this reflected wavelength value changes. There is a shift. If it is compressed, there is again a shift in the other direction. So this is the wavelength shift that we monitor to measure the strain on the fiber. Okay, and it is also sensitive to temperature. And then scientists have made variety of transducers with this. So I would show you how we are using it in the railway domain. See, we use this on the railway track, as this small video shows. See, the fiber is here between the two yellow lines. There is an FPV fiber. This is actually a train. I think it was Prashanti Express, in which we have captured this data. So whenever there is a wheel over the sensor, this gets bent and the fiber gets stretched. Then there is a wavelength shift which is captured, and what you see here as a pulse. So this is how we are monitoring it. I will just run the same video at a slow motion so that you can get a better idea. So this is what you are seeing is the data that we capture, and that is the data with which we are able to work. And then after that, it's all data analytics. Okay, so this is for a full train data. When the entire train has gone over that, we get something like this. The upper one is for Rajdhani, the lower one is for Shatabdi. And you can see we can count the peaks. So here we can know one thing that you can see by counting these pulses. We know exactly how many wheels, how many axles have gone. But more interestingly, since we are measuring a strain, we are also able to distinguish and define what has gone. Say, for example, this is the typical signature of a locomotive, 3 axles per 3 axles. Then this one is a heavier one other than coaches. So this is the first class AC. That is their signature. This is the Shatabdi Express, which has chair cars. So these are the signatures for the chair cars. And this one is the power car of Shatabdi, which carries the generator. So by analyzing this information, we are able to give far more information than just axle counting. And that's why we call it axle counter plus, though the main purpose is axle counting. And this is the expanded view, which I was telling you. This is the locomotive signature. This is a loaded goods wagon. This is loaded wagon versus unloaded wagon. So we can also tell them that, look, in the goods train which has gone, out of 40 wagons, 10 were unloaded and 30 were loaded or whatever. So this is one which has been already been done and which has been under test. Third one which we have done and deployed is called Wheel Impact Load Detector. This is a system to automatically check all the wheels that pass over the instrumented section for any defect in that. So this patent has not been granted, it has been filed. It has been filed jointly by Lab to Market and RDSO, Lucknow Railways. So this is a system to detect defective wheels before it causes damage. You see, the wheels get defected because of the failure of the brake or a variety of reasons. So this is a minor defect. As you can see on the right side, this is a minor defect. There is a flatness that has come. And if it remains unattended, in extreme case, it can even go to this extent, which is bound to cause a derailment or accidents. Okay, so but even this can be very dangerous. What it does is that it damages the track, even though there may not be an obvious accident or anything. But all of us have traveled in trains, or we have heard sounds of duck, duck, duck. That happens typically because of flatness or out of roundness of the wheel in that. And while this may not affect, this may be just a nuisance to the passengers, see what it can do to the track. And once the track gets damaged, it's a terrible thing for the railways. They have to replace it, and replacing his track is a very, very expensive affair. And in the extreme case, of course, it can cause derailments. So this wheel, how we do it is, again, we use the same FPG and we monitor the signature. Now, when there is a flatness, it's out of roundness, the impact on that is much more than a normal wheel. So this is a typical signature of a train where is one wheel is defective. So you can see that all other signatures are normal. This fellow is giving a very high strain. Definitely there is some problem. So we use again data analytics and some little bit of machine learning to identify these wheels. We know the identity, we inform them that, okay, the train which has passed, that has a problem. Recently in a passenger train, our system alerted that there was a critical alert. When our system finds something critically bad, then an SMS and emails are sent to concerned person. And then we have actually two such systems installed in Bangalore, one in a place called Yalanka, another in Whitefield. So the Whitefield area is that where the trains come from Chennai side to Bangalore. And there was one express about a month ago in which our system sent a critical alert. It was a passenger train, and the train, when it was stopped, they found the wheel was very bad, and then they did not allow it to go further. It was detached. So later on, the depot in charge told us that if it had not been detached, anything could have happened. So this is a very significant system needed for railways, which we have already developed and deployed. So as I have already said all these things, I need not repeat it, but there are two systems which are already operational for nearly 1 year now. I will show you a small video about this while, so you can get full idea.
Welcome all. Greetings from Lab to Market. This short video is a walkthrough of RDSO project FPG-based Wild, implemented at LC15, Kenchanahalli, Yelahanka, Bengaluru. Let us begin with the glance at the project site. This cabin is the on-site workstation of our scientists. We are now at the entry point of the wild zone. A train wheel moving over the sensors T1 and T2 triggers the system into action. Information from these sensors are conveyed to the system through Fiber Distribution Management System 1. This is the measurement zone, comprising 20 FPG sensors in all. Twelve strain sensors to monitor the vertical load exerted on the rails. Four vibration sensors to monitor the oscillations of the rail. Four lateral load sensors to monitor the lateral forces exerted on the rails. All these sensors are connected to FDMS2 and FDMS3. The exit side trigger zone consists of two FPG sensors T3 and T4. Information from T3 and T4 are routed to the system through FDMS4. When all the wheels recorded at T1 and T2 exit from T3 and T4, the system stops recording the data. This location box houses the entire wild equipment. Signals from all FPG sensors routed through FDMS boxes are connected to the 4 channels of the interrogator. In this implementation, the east side vertical load sensors and the exit zone trigger sensors are connected to the channel 1, Entry zone trigger sensors and west side vertical load sensors are connected to channel 2. The lateral load sensors are connected to channel 3. The vibration sensors are connected to the channel 4. The interrogator sends data to the data processing unit. DPU processes the data and transmits the processed data to the Realtel cloud through the CDOT gateway. Wild system is powered by battery backed uninterrupted 24-volt DC power supply. The processed information is organized in the cloud server for the authorized users to view through a customized GUI. Greetings from.
So this was the wild system at LC15. Now we have also implemented few more systems, smaller systems, what we call, there is a device called WSPD, which is mounted on the new coaches of Indian Railways. They act like, ABS of our automobiles, which they detect the slipping of the wheels for some reason and take action. But those devices, when they are working fine, but they are not very reliable and they go bad. And once they go bad, it is not known to the driver that my WSPD is not working. Only at the next monitoring station it is detected. So even though they like WSPD, its usage was very limited because of this factor. Because many units will go bad and the driver will not know. So we have made an overlay on that, and which monitors the WSPD device in real time. And if something is not working, then wirelessly it is informed. So that system also has been implemented in 4 Rajdhani trains, which run between Bangalore and Delhi. And just yesterday, we have been given an order for another 4 trains when we want to do that. Other first system has been running for quite some time. So this is basically the new coaches called LHB coaches in which it has been mounted. Okay. Then what another very significant study we have taken it is that we are now working on FPG based structural health monitoring. Again, this was taken up for a customer, K-Rail. K-Rail is an organization, joint venture of Government of Kerala and Indian Railways. They are setting up a new railway line from Trivandrum to Kasaragod, about 530 kilometers. So there are some difficult areas which is very heavily rain prone and landslides happen. So they want to monitor all the structures like bridges, viaducts, tunnels for their health. And they approached us whether we can take it up, and we have taken it up. Now the one study is already going on. So typically structural health monitoring is done through strain gauges, conventional strain gauges and all that. There are so many advantages with FPG. We have decided to work with them, and the work is already going on now. I would say the proof of concept is now being conducted. Here we have partnered with the SERC Chennai because they have the required facilities to assist us. And these are very important. These things are monitored. We don't have to go into detail, but what we are doing is we are working with them SERC. This is a photograph taken at SERC's. One of the testing is going on. This is an I-beam used in bridges. So we have mounted FPG sensors and all that. And then this is being subjected to different kinds of loadings, vibrations and all that. And the response is being monitored. Now the next stage, we are going to embed it into the concrete beam. And then we're going to repeat the same experiment. After that, the third phase would be that we would instrument an existing rail bridge and then prove it. For that, this is a paid project from Kerala Rail. So this work we are starting, and this is likely to become a very big thing for the country, because nobody in the country is doing structural health monitoring with FPG. Then we have also done some proof of concept which definitely done for the first time in the world. Nobody could ever imagine that the brakes, condition of individual brakes can be monitored whether the brake is applied or not physically in a running train. We have demonstrated it with the FPG, and also temperature monitoring of axles is also a very critical thing. Now it is done at designated points. A person goes with an infrared thermometer and checks the temperature of all the axle boxes. But while the running train, if there is any problem, it is not known to anybody. So we have demonstrated that it can be done. And we did it twice actually. Of course, thanks to railways, they permitted us to do that. So in the Bangalore to Chennai Shatabdi in May 1st, and again on their request on May 8th, we did that. We mounted FPG sensors on the axle box and on the brake lever, okay, and also on the suspension. And this is a faculty member, Dr. Sunita from IIC. She's an expert in FPG, and she was monitoring. This is the interrogator, and she was monitoring in the laptop. So we found that it works very well. This is for the brake. As you can see in the running train, we are monitoring one brake. Here the brake was released. Now the driver has applied the brake. This means that the brake has been applied. Now the brake is being released. And so it is going. So we are going to measure, we are able to measure actually how much, not only that the brake is applied or not, how much it has been applied, how much pressure it is exerting. In a running train, as you can see, it is recorded when the train is running in that. So this we have proven twice. And again, this is the graph of the temperatures recorded at the two sides of the same axle. The bearings are on the two ends. So these are the two temperature rises recorded during the entire run of the train. The train leaves Bangalore at around 6 in the morning. So this is the temperature rise. It shows zero temperature rise at that point. And as the train starts running, you can see that quickly the temperature rises. Okay. Maximum temperature here, I also was there in the second run. At this point of time, you can see the temperature rise got about 90 degrees and maximum temperature, and the speed was about 110 or so kilometer per hour. Ambient temperature around 30. So the axle box temperature would have been 120. And this was a revelation to the railway people because they never knew it gets that hot. Because when they monitor after stopping, as you can see here, the train has stopped at Chennai, the temperature has dropped already so much. So by this instrumenting like this, every second the temperature can be recorded. And also they were surprised to see that there is a substantial difference between the temperature on the two sides. So apparently one bearing is better than the other one in the same axle. Okay. So these are some of the things that we have already done. And thank you very much for this time and patience. And if there is time and interest, I am willing to take questions.
Thank you, sir. Thank you for this wonderful session. So now I request the participants, those who want to ask queries, they can unmute themselves. They can raise their hands and we will unmute you. Or else you can also use the chat and Q&A section to post your questions. Sir, there is a participant, Mr. Gulab Patel. He wants to ask queries. Sir, with your permission, shall I unmute him, sir?
Yeah, please.
Hello, Gulab Patel. Can you hear me?
Yeah. Good morning, sir. Can we install these sensor on the roads other than the railway track? And second question is, can we use the same sensor to monitor the health of the roads, as you mentioned for the railway track?
Yes, we can do that, but these sensors are actually point sensors. So when you mount it at some place on the track, it monitors a very narrow zone. In our case, our sensors sensing zone is about 60 centimeters. So if you want to monitor the health of the track by APG sensors, you will require a very large number, which is not practical. So I would say that it is theoretically possible what you are saying, but it's not techno-commercial as view if you take, it's not viable. We have to think of something else.
Okay, okay, got it. Okay, thank you, sir.
Thank you, Gulab Patel, for your query. So, dear participants, those who want to interact in the session, they can raise their hands. We will unmute. So, sir, I guess all the queries are being answered. So, thank you, sir. Thank you for joining and enlightening us. Yeah, one of the participants, Sayed Ali sir, said, excellent work by you, sir. Thank you, sir.
So thank you very much for having me and have a good day. Thank you. Well, thank you all. Thank you everybody for their patience.
Thank
Bye.
you, sir. So on behalf of the principal coordinator of this program, Professor Ratnajit Bhattacharya sir from IIT Guwahati, and also the principal coordinator of this program, Dr. Bharat Gupta sir from NIT Patna, I thank you, sir, for accepting our invitation from ICT Academy and coming on the dais and sharing your knowledge with us, sir. Thank you so much, sir.
Thank you for having me. Bye.
Thank you, sir. Thank you. Bye. So, dear participants, shortly we will start with the next session. So, we request all the participants to please be online. Our next expert will be joining us shortly. Thank you all. Good morning, Amit sir. Hello, Amit sir, am I audible?
Ma'am, hello. Yes, ma'am.
Yes, sir. Yes, sir.
Ah,
Yes, sir. Now
so,
you're audible, sir.
yes, yes, yes. Ma'am, let me know when you want to start. Okay.
Yes, sir. We have made you the presenter in the meeting, sir. You can share your screen once.
Okay, okay. Let me check. One minute. Hmm. Arey. Uh, Ma'am, is it visible?
Yes, sir. It is absolutely visible, sir.
Okay, okay, okay. So
Okay,
let
sir.
me know when we want to start. Then we can start. There is no issue. Okay.
Okay, okay, sir. So, dear participants, so we will start with our next session. So before we start with our next session, we will have a short introduction of our next speaker. Dr. Amitam Joshi completed his MTech and PhD from Sardar Vallabhbhai National Institute of Technology, Surat, in 2009 and 2015, respectively. He is currently an assistant professor at Malviya National Institute of Technology, Jaipur, since July 2013. His area of specialization is biomedical signal processing, smart healthcare, VLSI DSP systems, and embedded system design. He is a senior member of IEEE, member of IETE, and member of IEEE. He has also published 90 plus research articles in excellent peer-reviewed international journals, conferences, and also has published 6 books chapter. He has a total of 734 Google Scholar citations, I-10 index 23, H index 15. He served as a reviewer of technical journals such as IEEE Transactions, IEEE Access, Springer, Elsevier, and also served as a technical program committee member of IEEE conferences like ISES 19, ISES 20, ICCE 21, and ISVLSI 21. He also served. Uh, he has also received the honor of UGC Travel Fellowship, the award of SERB DST Travel Grant, and CSIR Fellowship, and also attended well-known IEEE conferences like TenCon 16, TenCon 17, ISCAS 18, Manacom 19, etc. across the world. He has served as a session chair at various IEEE conferences like TenCon 2016, ISES 2018, ISES 2019, ICCIC 14, etc. He has served as track chair in ICCE 2021, publicity chair of ISVLSI 2021, and program vice chair of ISES 2021. He has also served as mentor for IEEE Engineering in Medicine and Biology Society under Student Mentorship Program 2021. He has supervised 4 PhD theses, 25 MTech dissertations, and 19 BTech projects in biomedical signal processing and VLSI embedded systems. With this, I welcome you, sir, on this platform to deliver lecture 11, IoT for healthcare. Over to you, sir.
Thank you, ma'am, for such a nice introduction. So, good morning, all of you. So, I believe that in this particular FDP, you have gone through IoT concept and the different application of the IoT. Okay. So, specifically in this particular lecture, we would like to go through a role of IoT in a healthcare, and we will also discuss some of the smart system where IoT could be used, and even I will also give you some of the application where I have worked on and where I have used the IoT. Okay, so let's start with earlier we will first discuss about the traditional healthcare towards smart healthcare. What do you mean by smart healthcare? And when we consider a smart healthcare, then role of the IoT and AI is very crucial. Then we will talk about the different model of the smart healthcare. Then we will talk about different electronics healthcare application. Then we will talk about some of the application with the machine learning and IoT, which you can use it during this pandemic time. And then we will have a challenges of IoT and AI in healthcare. Now, when we talk about healthcare and we consider whatever the traditional healthcare system, in a traditional healthcare system, what will be the case that if some person is in serious condition and if he is being admitted in an ICU, then we require one dedicated staff who will take care of the patient all the time. So you require a dedicated staff to be there for 24/7. Okay. Now, in absence of that dedicated staff, it could be a possibility to go to a loss of life over that particular person if the proper treatment is not being provided at that particular time. Now, when we talk about the traditional healthcare system, then in a traditional healthcare system, we have so many stakeholders which are being involved, but they are not actually talk with each other. Like if I am ill, then possibly I will visit a doctor. Doctor will give you some sort of prescription or he will suggest some test to me. I will go to a laboratory, then I will go for such kind of test. Then whatever the reports are that I will show, then doctor will prescribe. I will go to a medical shop. I will go to a purchase of those medicine. So here basically all the stakeholders which are related in the healthcare, like doctor, the laboratory, clinical laboratory, your medical shop, all are in decentralized manner. Okay. So first of all, in a smart healthcare, we want them to be connected with each other. And IoT will play a very crucial role where they can be talk with each other on a same platform. So centralization of this is very important of all the stakeholders in a smart healthcare. Now, when we talk about the smart healthcare, in a smart healthcare, whatever the smart sensor that we have, that would capture a lot of information. So basically for the health sensor, we expected that health information are being generated. So that data, whatever is being generated, that you can send it to a remote location where doctor will give you a prescription, and with of that, you can have some sort of preventive action. Apart from that, you can actually go for a continuous health monitoring in some of the chronic disease. So chronic disease are some disease that which actually gradually occur inside our body, like diabetes, cancer. So if such kind of chronic disease are being diagnosed at early stage, then you will provide a better treatment for that. Okay, but ultimately you require to monitor them continuously. Okay, so with that you can find out that at which particular stage you are, and if you identify them in the early stage, then definitely it could be cured very easily. So smart healthcare solution would provide a monitoring, some sort of healthcare automation. They can also provide a drug delivery mechanism, and they will be very useful in preventive healthcare system. Basically, when I use a IoT concept in a medical domain, then we used to term them as a medical internet of things, or sometimes we used to term them internet of medical things. Okay, now over here, the sensor would be there, which will collect the data. On those data, we will run some sort of machine learning or AI algorithm, and through which we will try to derive some useful information. And that useful information is very useful to have some sort of treatment towards the patient. Now, basically in a healthcare domain, when you have a software and hardware all together and in some sort of embedded system, then that basically we term as a healthcare cyber physical system, where you have an embedded software which will taking care of the process, complex algorithm, where complex algorithm is running, and there are dedicated hardware which we consider as a sensor which will collect the data. So this overall system is actually being defined as a healthcare cyber physical system or They also term as a medical cyber physical system. Now we will see a different component of a smart healthcare, okay, which we can use it in our day-to-day life. So first, when we consider a smart healthcare, then basically in a smart healthcare, we require some sort of facility that we can avail either through an internet, okay, so that we consider as an e-health, which is one of the important component of the healthcare, m-health, where we are using a mobile phone, telemedicine, where doctor and patient can meet with each other at the remote location, and it could be very useful in current scenario, or basically during the COVID-19 peak season, where actually people are not able to meet with the doctor personally, because with the old age people, for them the frequent visit of the routine checkup is very important. But at that time, doctors are also reluctant to meet the patient because of the COVID-19 infection. So at that time, the telemedicine could be very useful component which could be utilized, and as well as a connected health, which I will just talk about that, where we want that all the stakeholders related to healthcare domain should talk with each other and should share the related information. So role of ICT is very important over here. So whenever we have a sensor which will collect the data which is related to healthcare, then that data we used to term technically as an electronic health record. Okay, and this electronic health record is very vital. Okay, based on them only you will take some sort of decision about the health condition or illness of a particular patient. So over here, the data collection by a smart sensor would be done, but definitely you do not want to process at the node end, but definitely you want to process at the server end, where you can have a support of the higher complexity, where you can run the complex algorithm. Okay, because this AI algorithm is very complex in nature. So for them, from the sensor end, you need to transmit them to a remote location where actually this such kind of data processing algorithm runs, and you will get some information. And we talk about smart healthcare component, then these are the some attributes we are expecting from the smart healthcare, like they should be connected with each other. They should not be something related to a location specific. They should have some sort of sensing facility. They should be always on, because we want that 24/7 we should able to monitor our health condition. They should be multifunction, which is very important. Okay, so ultimately we want to get some important physiological parameter from our body, but we do not want to wear so many sensors on our body, because we want to move around. Okay, we want to go for our routine life. Okay, and during our routine life only there has to be some variable sensor, so that we can capture our data, and whenever the sensor sends some critical value, then it should warn you to take the preventive action accordingly. So characteristics are also very important in smart healthcare, where you should have some sort of intelligence. It should be responsive, it should be sensitive, it should be personalized, which is very important. Okay, because sometimes you will observe that by having a personalized data from a person, you can actually think about the personalized solution, because generic solution may not work for all the time. Okay, because each and individual body structure is a different one. Okay, so actually with this, what would happen, that the data which is being collected by that particular patient only, and through which only you are taking some decision. It is not like a general decision that you are taking, and that way also smart healthcare is very important and very useful. So basically in a smart healthcare, doctor and patient can connect to a remote location. Continuous monitoring is possible. You can take the corrective action and quality of the care. You can have a real-time access of the patient data. That means it is as good as you are physically present over here and you are observing the patient. So similar way, the data which is being captured, that you can observe through a remote location. Okay, so maybe through a mobile app, you can just view the condition of the parents which are there at your home. Okay, so it would be very useful for taking care of the old age people. Similarly, we can provide the better point of care service through some sort of intelligent consumer electronics devices. Now, when we talk about the consumer electronics devices, then there are some consumer devices which are already placed, like a smart ring, smart belt. You have a smart clothes, smart watch, which is being developed by Apple, which is very popular among people. Okay, so they are actually capturing some important parameter from our body. Maybe they are they would be useful to capture EEG, ECG. So this parameter actually you need to monitor. They will give you the actual health condition in your day-to-day life. Now, these are the consumer devices which are available, but still they are not popular because of some reason. Because of the first of all is a precision, because when we are talking about the health record and through which we want to take a decision, then first of all your data has to be precise. Then and then you can take some sort of accurate decision based on that. So that is currently a problem. Whatever the consumer devices which are available, they are not enough precise as well as reliable on which you can take actually a decision. So of course the cost is also one of the prominent factor, because they are not actually appealing to a common people, because they are having a very high cost. Now, e-health is one of the solution where we use ICT and internet very extensively. Okay, so over here, basically you can provide some sort of health information to a profession as well as some patient to take care of the decisive action at a time of the critical condition. Now, M-health is a very important component, because in a M-health we use a mobile phone to provide some health related information to an end user. Now we consider that mobile is a very convenient component to reach out to somebody. We expect that in our country only, maybe 60 to 70% of the people is having a mobile phone. Okay, so it is very easy to be connected with them. Now through a M-health, basically you will use some sort of mobile application in a healthcare domain. One of the application we are using extensively right now, like a Arogya Setu, even CoWIN we are using. Through a CoWIN we are actually going for a vaccination register. So these are all under the category of M-health. Okay. Apart from that, you can also send some sort of public awareness message through a SMS, so that in a large community you can circulate some sort of awareness campaign. Of course, the real-time monitoring of the patient and vital sign you can always track care through a mobile phone. So in a mobile phone, we have some of the application currently available through which you can actually check some of the important parameters. Now, mobile phone could be very useful for a rapid collection and a data sharing. It could be helpful to send a public message. Medical alert can be sent. Even doctor can think about using a sorry. Even doctor can think about sending e-prescription through a mobile phone. Telemonitoring could be also useful to transmit the patient useful information. Even some of the laboratory now support a mobile based application where you can view the report. You do not have to actually go physically to collect your data. Of course, to provide your sample, you need to go to a laboratory, but while collecting the report, it is not necessary. So such kind of techniques are already in the place. The last component of the smart healthcare is a connected health. Now, connected health is a very important, where we want that all the stakeholders should be connected with each other. It is something like that if I visit a doctor, then doctor should prescribe a medicine and that should be stored on some central server. Now, whenever I go to a medical shop or whenever I go to a laboratory to go for some sort of test, now that laboratory person should observe that whatever is being prescribed by a doctor is even the medical shop person would also take care of whatever is being prescribed by a doctor, and accordingly they will provide the support to a customer. Apart from that, connected health will definitely help us in a insurance claim policy, because currently what happens that if you are being admitted in a particular hospital, then you have to be for a certain duration at the hospital. Then some of the person of the mediclaim would visit them. They will actually monitor your condition. and then your claim would be passed. Now, through a connected head, what could be the scenario that whatever the data which is being provided on a central server, the person can simply look at that particular data, and according to that, your medical claim could be passed. Now, such kind of facility or such kind of system are already being placed in a Western country. Okay. Of course, in our country also, we are expected that it would be available very soon. Now, I think before 1 or 2 years back, when our Honorable Prime Minister addressed on a 15 August, at that time he mentioned that every Indian is supposed to get one digital ID, which is unique for each and individual. And according to that, all the information or all the health related information will be stored over there. So that means you will have a one particular ID on which you will have all the information. Even you can track your past history, that before 2 years, that what was the situation of that particular patient, and that actually help the doctor also to take the or to provide the proper medicine. So IoT framework in a health monitoring is used of various way. Okay, maybe you can have some variable blood pressure, even you can have some sort of pulse oximeter, you have some sort of pedometer. Through this sensor, the data is being captured, that data could be stored. Okay, and that data you can view it at the end of the day, that what was your health condition throughout the day. Now I will talk about some of the applications where I have worked. Okay, so one of the application where means I am working for the smart system development along with the IoT is a diabetes. Now, diabetes is, you can consider, a crisis of this particular century, where you have around 422 million. This is the data of 2019. But to be honest, the latest data is more than 450 million people around the world are suffering from diabetes. Now, when you are a diabetic patient, then for you, you need to measure your blood glucose frequently throughout the day. Ideally, you should measure your blood glucose at least 3 to 4 times in a day. The glucose of your body will vary time to time. Means if I measure the blood glucose presently of my body, maybe after half an hour, this glucose value is completely different. Okay. Even when you go for a blood glucose measurement test, then you need to give a blood sample before meal and after meal. Okay, because certain period of time, that particular value, you will get the substantial change. So overall, if you are a diabetic patient, then you need to go for a recurrent blood glucose monitoring or a continuous blood glucose monitoring. Now, when you are a diabetes patient, then also you need to take care of your diet. Okay, what you need to eat and what you do not need to eat. That also very important. Now, currently, there is no smart healthcare solution which are available to address this concern of this large community of the diabetic patient. So we have worked on that and we have developed some solution. But before that, when we talk about the diabetes, then you cannot take the diabetes is very lightly. Okay, because diabetes is actually root cause of so many problems with your body. Like it can damage your nerve system, it can damage kidney, you can have a cardiovascular disease problem, or you can have a eye damage. So all these problem is actually being generated because of the root cause of a diabetes. Now, when I consider a diabetes, then diabetes is also identified initially by some sort of symptoms. Like you can have a frequent urine excursion in a short duration. You will find out the hungriness and thirstiness consistently. You can find out the unexpected weight loss, tiredness. You can have observed the vision changes. So all these are the initial impact of a diabetes. Now, if you are a diabetes patient, then chances of death is 50% more than a non-diabetic patient. Okay, so that's why you need to manage your diabetes very cleverly. Now, if we talk about the data in India, then more than 70 million people are suffering from diabetes in India alone. Now, when I talk about the diabetes, then diabetes is of 3 categories. Okay, so mainly 2 category, type 1 and type 2. Third is the gestational. So this diabetes category is occurring during the pregnancy of a woman. Okay, and that is a temporary diabetes. Okay, so once the pregnancy of the woman is over, then she would be fine. But of course, C has to take care so that C may not be enter into type 1 and type 2 diabetes. So type 1 and type 2 diabetes is a main category. Okay. Now, that also depends upon the insulin generation inside the body. Now, when you eat something, then through this food, the glucagon hormone is generated inside the pancreas. Now see, glucose is very important parameter of your body. It is not like that if you do not require a glucose. Actually, you require a glucose. Okay. And to perform your daily activity, you need to take actually you should have a sufficient glucose inside your body. So if you observe that if you are hospitalized into some sort of disease, then the first thing will doctor put you in on glucose bottle. Okay. To just ensure that you have a proper glucose inside your body. Now, glucose is normally measured in mg per dl unit, and in a normal or healthy patient, 70 to 150 mg per dl is considered a normal glucose rate. Now, if your body blood glucose increase greater than 150, then it is considered to be a hyperglycemia, which we term as a diabetes. Okay, so if your glucose value is greater than 150, then you are a diabetic patient. Now, if your glucose value is less than 70, then we consider as a hypoglycemia case. And to be honest, that hypoglycemia is more dangerous than your hyperglycemia or diabetes. Because if your body having a blood glucose value less than 50 or 40, then person can go into a coma as well. Okay. So glucose in a precise range is very important in our body. Now, how you can identify that? By measuring it frequently. Now, once you eat something, then in your pancreas, the alpha cell are there, which actually generate the glucagon, which actually contribute towards the higher glucose value. Now, at the same time, the beta cell is there, which will generate the insulin. Now, with the age, or maybe because of some deficiency, what happens that your pancreas is not able to generate enough insulin inside your body, and then the problem will start. So actually in your body, the glucose insulin balance is very important, and that you need to maintain. Okay. Now, in a type 2 diabetes patient, what happened that whatever the insulin which is being generated, that is not adequate enough. Okay. So insulin generation to ho raha hai. That means insulin is being generated, but that is not adequate enough to actually neutralize your glucose value. And in type 1 diabetes, your pancreas is not able to generate the insulin at all. And because of that, you will observe that some of the patients are taking insulin injection before taking a meal. Okay, just to ensure that they want to inject the insulin inside the body. So after taking a meal, whatever the glucose is being generated, that will be neutralized with the whatever the insulin they have just taken. Okay, so ultimately in type 1 diabetes, this insulin is absent, so that's why they need to take it externally. In a type 2 diabetes, usually they could be reverse. Diabetes could be reversed in a type 2 diabetes mainly when you take some sort of precautionary action early. But for that, you should know that when your blood glucose is getting higher. Now, in order to get that knowledge, ultimately you need to go for a continuous glucose monitoring. As I said, that 3-4 times in a day is a minimum requirement. Okay, so that you can manage your blood glucose of a body very wisely. Now, for that, whatever the present technology which are available, which are invasive in nature. Invasive in nature means you need to take or you need to prick inside your body. So you need to actually take out the blood sample from your body part, and from that blood sample, you can measure your glucose. Now, if we consider this approach to adopt in 3 or 4 times in a day and for a longer duration, it is creating a problem. Okay. And especially the diabetes occurs with the age. Okay. So for the old age people, once you enter into 60 or 70, then it would be very difficult for them to go for a frequent pricking and taking out the blood sample out of your body. So for that, you need to think about some sort of clever solution, which is non-invasive in nature. Non-invasive in the nature, that means from the outer surface of the body only, you would be able to measure the blood glucose value. So that's what we have done it. That means we have identified a optical detection approach, which actually help us to measure the blood glucose value non-invasively, where you need to just throw a light onto a body, and at the receiver arm you need to find the intensity of the light. Now from this intensity you can predict the blood glucose which is being present inside your body. Now definitely the intensity of the light would vary according to the glucose which is being present inside your body. So for that, actually, if you want to go for optical based approach, then you need to think about the light source, which light source is better for you. So for that, we have done some experiment and we have understand the glucose molecule formation. And through a spectrometer, we have done experiment where we have taken a simple water, then we have taken a glucose bottle of a concentration of 5G, 10G, and 15G of the glucose, and then we have observed the spectrum, and through which we have observed that 940 and 1300 nanometer, two wavelengths are there at which the glucose particle could be detected. Okay, so that LED we have used in our experiment, and through which we are measuring the blood glucose non-invasively. Now, whatever the approach that we have used over there in an optical, we have used the absorption and reflection for two wavelength. Okay, so 940 nanometer we have used the absorption as well as the reflectance, and 1300 nanometer we have used only absorption. So through these three sensors we are getting a voltage value at the detector, and that we are using in our machine learning model, and through which we are predicting our glucose value. Now this we are measuring with the standardly available device which are available. Now currently there are some self-monitoring device available in the market which you can purchase. So AccuCheck, AccuSure, Dr. Morphine is also giving that. So over there is a lancet and there is a strip. Now you need to take through a lancet, you need to pinch inside your finger or any part of the body. You need to prick the blood and you need to measure the blood glucose. Okay. So we have compared our result of the non-invasive glucose measurement with them. So for a same subject, we have taken a non-invasive measurement glucose reading, or that we have predicted, and the same for a same subject, we have taken a blood pricking method and observed a value, and through which we have observed that we are getting almost 90% of the accuracy for a blood glucose measurement. So this is just an experiment that we did, that we have prepared the solution, and through which we have observed a wavelength at which the glucose particle is being observed. This is just a setup that you will observe that there is an acquisition module and there is an Arduino board. So Arduino board that we have used just to data logging to a computer, and on a computer we are actually running the machine learning model. So that is a regression model we have used to predict the blood glucose. So this is just a slide to just showcase the what is the invasive and non-invasive. So as we discussed, the non-invasive actually more suitable for a continuous health management for a diabetic patient. So ultimately what we have done, we have developed the glucose measurement device which actually help to measure the blood glucose non-invasively. That glucose device we have termed as an iGlu. So that iGlu device that we have developed, which is an intelligent glucometer, now that will capture the value and that will store the data at a cloud. Okay, so we have used the IoT. Through a IoT from that device, whatever the value which is being captured, that will be stored at a cloud. So it will be remain over there and you can view it, your data, for a longer duration. Okay, so that means before 15 days also you can get back the value of that particular time. What is your blood glucose value? So that you can observe, and that actually help you to have a better glucose management. This is just a pictorial representation. You just observe that a three finger you need to use, because we are using a three sensor, and through a three sensor we are actually able to get the prediction. Now apart from that, always when you say meet a doctor, then they ask you to go for a laboratory testing. Okay, of course self-care device that you use, self-monitoring device that you can use at your home, they are useful. Okay, because you cannot visit a laboratory, means 7 days in a week. Okay, so ultimately you need to do it at some point of time, maybe once in a month, or maybe once in a 2 month, like that. But that laboratory method is considered to be precise than whatever is available method of self monitoring device in the market. The reason is laboratory method is somewhat standardized, which actually help you to find out the serum glucose. Okay, and whatever the device which are available in the market that measure the capillary glucose. Okay, so when you visit a laboratory, then whatever the blood sample that they have taken, through which they are putting into some sort of temperature chamber, and they are actually partitioning your heavy component of your blood, and then you are having some sort of component this which you will use it for the glucose measurement, and that is considered to be more accurate. So what we did in our experiment, that we have compared our result. So initially, for a model preparation, we have trained our model and calibrated our value with the whatever the laboratory based value are available, and through which we have developed our glucometer, which we consider as the second version of the glucometer iGlu 2. And with that, we have observed that we are getting the 3 or 4% of the more accuracy. Now we are able to get 93-94% of accuracy with the accurate blood glucose measurement. Now these are the sample that we have considered for our experiment. Okay, so we have considered diabetic, pre-diabetic, and healthy patient, and we have tested our device. Now once you come up with any glucose measurement device, then you need to pass and validate through a Clark error gauge analysis. That means you need to take a reference value and estimation value, and you need to compare both of them. Okay, if both are similar, then possibly you will get a linear curve where you will rely your value lies in a zone A. So if your values of the predicted device is residing in zone A, then it is considered to be clinically accurate device. And whatever the 97 sample that we have collected till date, that all the sample are coming in zone A only. So B, C, D, E are some of the zone which is not advisable actually for a clinical or medical purpose. But if your values are in zone A, then you can use it. Okay, and means we are getting all the value in zone A only. This is just a comparison of our device that with MARD. If you just observed it, that error is minimum in our case compared to all other previous efforts. Now, this we have integrated with the IoT. As I said, that whatever the value which is being captured by a sensor, it will be stored at a cloud. Now, from a cloud, the whatever the data is there, now through which you can decide that what kind of insulin you need to inject inside your body. So specifically your type 1 diabetes patient, they used to take the insulin injection. Okay, but they are not measuring the blood glucose value at that point of time. Okay, so this is sometimes is a very dangerous situation. Okay, because we need a blood glucose in a specific range. Your blood glucose cannot be lower than some limit, then it would be creating a problem. Okay, so now for them we have used some sort of, or we have developed some closed loop system where through our intelligent glucometer, the device is capturing some data, it is being stored at a cloud. Now from a cloud you can view that data, even a doctor can view the data, and they will prescribe a specific insulin dose that you need to inject inside the body. It is not like that irrespective of your blood glucose value, you will take the insulin dosage. So currently this is the practice is being placed in most of the diabetic patients who are at an insulin. But with our device, what would be happen that you will measure your blood glucose, what is your current value, and accordingly what amount of the insulin is being required, that will be decided by a model, and accordingly that amount of insulin you will inject. Okay, so here also the IoT will play a very crucial role, because from the sensor data, the data is going to a basically server. At a server, all the data analysis has been done, and through which some insulin dosage is being fixed up, and that is being injected inside the patient body. So basically this is just a closed loop system to just show that if your body glucose value is more than 150, then possibly whatever the data is stored at the cloud with the doctor consultancy, you can decide that what kind of medication you need to follow. Another application where we are working is upper limb prosthetic control. Okay, so when you lost your hand, maybe because of some reason, if your hand is not there, then it would be very difficult to manage your daily activity, because hand is a very important organ of your body, and you do your most of the work throughout the day through hand only. So what we thought that we can just think about some sort of smart solution for this kind of device who are is the upper limb amputees. Now, so for them, you can consider a robotic arm could be developed, and that robotic arm could be controlled through a brain signal. Okay, so that means whatever the signal which is being generated through a brain, you are decoding that signal, and through decoding, you are passing the command to your robotic arm, and your robotic arm will perform the movement accordingly only. So that's what is expected. So this kind of robotic arm prosthetic device are already there. Okay. Now this could be operated in a either of way. Either you can use a EMG based or EEG based. So if a brain generate a signal, then if you capture those signal at a scalp of your head, then it is EEG. And when you capture at the muscles of your body, then it is considered to be EMG. Okay. Now capturing a device at the scalp is always a challenging. Okay, so EEG based data processing is always challenging, because capturing of EEG is always difficult, but means it is comparatively easy if you have a muscles. Then through a muscles you can capture the device, or you can capture the signal, and through which you can find out the intention. See, signal is generating a brain through brain only, but that signal will travel through your different body part, and then whatever the signal which is available at the muscles, that you capture, and through that signal you are defining or decoding the intention of the user, and then that you supply to a robotic arm. That kind of solution is being deployed. So basically the EMG signal we capture, we will go for a feature extraction, then we will prepare a feature matrix, then we will identify which kind of classification, that means which kind of action a user want to perform. Okay, because there are so many activities that want to perform, but there are some basic activity that has to be performed by this robotic arm. So we have finalized that. Possibly I can think about the arm open, arm close, grasping of some material. So this kind of basic activity we have considered, and we are able to do it successfully. So this is the way you can actually capture the EMG signal from a body surface only. So surface electrodes could be there, and intramuscular electrodes are also there. So surface electrodes, that means you can measure from the outer body surface only. You can actually capture your EMG signal. Intramuscular is something like a needle is there. You need to inject inside your muscle, and then you are capturing the EMG signal. Now this is the actually the working there. Your brain cortex is generating the signal. First spinal cord will go to a central nerve system. At a nerve system, you have a motor neuron. This motor neuron is having some potential according to the different activity that we consider motor unit action potential. Now, this potential value will vary according to the different activity. Okay, so that means when I go for a hand open, then whatever the motor neuron activity or motor neuron potential which is being generated, that is different than when I am holding something. Okay, and that you need to capture it, and according to that you need to supply it a proper command to your robotic arm. So this is your overall flow of the myoelectric prosthetic control, where you will capture the signal to a surface electrode, then you go for a signal conditioning, then you go for some sort of data signal processing, and then it go to a prosthetic arm. So just to show you one video that which we have done it. So I'm just trying to go to a one video file. Hopefully it would work. I'm just opening the another application, and just let me know whether you are able to view it or not. Let me. Hello. I'm just sharing the another application. Okay. Please wait, because I want to show some video to you. I hope the screen is visible to you.
Yes, sir. The screen is visible, sir.
Okay, maybe audio may not be audible, but I will explain it. Okay. So this is just overall system. Just on the right hand side, you will observe robotic arm. Now I will show you some demo that different kind of robotic arm activity that we are able to achieve at our lab. Okay. So ultimately what we are doing that we are capturing a signal at the muscles. You just observe that this is actually me only. So at the arm, there are some electrodes are there. So that electrodes is capturing intention of a user, and through which it is going towards the acquisition module. So that red block is your acquisition module. Okay. Through this red block acquisition module, the data is being logged in to a system. So whatever the data is going to a system over which the machine learning part is being developed. Okay. So classification algorithm are being developed, and according to the proper classified activity, the particular command is being generated through Arduino, and that Arduino command is being supplied to your robotic arm. Okay. So you will just observe that when I open the hand, that arm will also open the hand. You just observe the next step. So this is the Arduino board. Now Arduino board will capture the command and it will go to a robotic arm. So just observe that there is a robotic arm over there. Okay. Now you just observe that it will capture my intention and it will do the functionality same as my hand movement. Okay. So you just observe that I am opening my hand. Okay. Currently I am closing my hand, and according to that, robotic arm will also perform the similar activity. So in this video, 3 activities is being done: hand open, hand close, and your holding of an item. So you just observe that hand open. Just observe I am opening a hand. This arm is also opening a hand. Now I am closing my hand. So arm will also close the hand. Okay. So that intention is being captured, and again I am opening, and just observe that arm is opening the hand. Okay. So ultimately through a brain, whatever the signal is being generated, now I am holding a bottle. Now just observe that I am holding the bottle. At the same time, the grasping is being done by a robotic arm. So it will have a the hand movement which will try to grasp something. Okay. So this kind of activity we are able to do it in our lab successfully, and actually we have deployed it, or we have tested it on an amputee subject also. But because of some ethical issue, of course, it would be very difficult to test more number of subjects. But definitely we are able to do it with the 4 subjects till now, and our model is working successfully in your amputee subject also. Okay. Now, just coming back to this slide, this is just how actually we are capturing the intention. Okay. So currently with the hand, I am actually going for the hand movement, and that is being captured. But when empty is there, then what we are doing, we are using a visual feedback system. So in a visual feedback system, what happens that there is a one mirror which is being placed, and if your left hand is not there where you are robotic arm, then through a right hand you are moving your finger and you look at the mirror. So at the opposite end, your left hand will also sense that signal. It is perceiving that I am also doing a such kind of movement. Okay. So with that, what happens that you will observe that your left hand is also moving because your right hand is moving, and you are means watching it through a mirror. So through which you will actually have develop your brain will develop such a signal that your left hand is also moving. So once this signal is being generated, then you can capture it very easily at your muscles, and then you can supply it to a robotic arm. It's kind of initial model that we have developed, and through which we are able to get it very successfully. Now, depression is also one of the major problem which we have observed around the world. Okay. So around 50% of the Indian are basically feeling some sort of mental problem, and 1 out of 20 are having a depression. Okay. So depression is one of the leading mental problem that is being observed. Now, basically in a depression, you need to actually observe the mood of a particular person. So now that is pretty much possible. Okay. So maybe you can have some sort of sensor which you can put it at a body part of a subject, and you can capture the movement of the particular person, because when a person is a depression, at that time he would like to remain, or he he remains in a loneliness. Okay, he doesn't want to move so much. So basically you can observe the movement of that particular person. Even you can have some sort of temperature sensor or humidity sensor that you can wear it on your body, and through which you can get some data, and through some sort of analysis you can take a decision. So such kind of work is already done. So such kind of smart system are already there, where through a sensor data is being captured. Now that data through a IoT, they have stored it at a cloud. Now AI algorithm will mine that data, and through which they will interpret some decision, and through which you can find out that person is being in a stress or not. And if a person is stressed, then what could be the exact stress level? Okay, because depression could be in an initial level, and if it is cure, then you can actually do a better, or you can go for some sort of counseling to that particular person. Of course, we are also able to do a deep learning based depression detection, where we are using the EEG. We observed that EEG is the best biomarker through which the depression could be detected. Now, depression could be detected by a variety of ways. Okay, maybe through a facial expression of a person, maybe through some sort of video analysis of a person, maybe through a speech. But we observed that EEG is the best one through which you can actually do the depression detection accurately. So we are able to develop the deep learning model through CNN and LSTM model, and through which we are able to classify the depressed person with the 99% of the accuracy. Now, if you are a diabetic patient, then as we have talked about that, you need to go for a your diet control. And even in a present way, in a pandemic, we are more worried about our diet and what we need to eat. Okay, so for that, there could be an intelligent diet control management system, which is already being proposed by some of the researcher, where what you can do that whenever you are eating something, then you can take out the picture of your food item. Now, more so ever, whenever you consume a particular food item, then what about the nutrition that you are about to get through this particular food item? This is already standardized. Even when you purchase a packed food, then you will find out that what about the nutrition is present in this packed food. But usually this is not possible when you having your normal meal or food item or vegetables, or maybe with the your fruits. So what you can do that there is some database which is being presented, through which actually the nutrition you can find out with all the food items. So what you need to do, you need to, when you are eating something through a mobile phone, you need to capture that image. Through that image, one particular food item will be classified, and according to the whatever the standard nutrition that you're supposed to get, that also you can get to know. So with that, you can actually manage your diet plan cleverly. That means if I eat something, then through this diet plan, you can decide that what could be my next diet plan. So suppose that in the morning I have taken something through which my blood glucose is high, then possibly at the end, at the night, I will think about taking some light food through which I can manage my blood glucose. So such kind of solution could be developed. Telemedicine, I have already talked about that, where the doctor and patient could be connected with each other, and it is very useful in our current pandemic time. So such kind of solution, whatever we are discussing, that is very useful in a current pandemic time. Similarly, robotics is one of the upcoming technology which would be available in our day-to-day life, where it would be used extensively in your tourism and hospitalization management. Okay, even robotics based application has already been placed during the COVID time for the sanitization purpose, to collecting the sample of the subject, or even for a food delivery. The robotics application have been used. Industrial 4, which is also very important to actually know about the smart manufacturing, smart production. Okay, so during the COVID second wave, we have observed that in a second wave there was a scarcity of the oxygen cylinder. But through an industrial 4 kind of setup, you can actually predict that at which particular location it is more likely the people who would be affected by COVID. Okay, maybe a population is one of the criteria through which you can actually manage your resources very well. Okay, so that you can provide the supply of a particular health related resources at a proper time to have a better treatment. Now, some of the challenges that we can have in a smart healthcare that I would like to cover. So most of the significant threat is a data privacy and security when I want to adopt IoT in a healthcare, because my data is being stored at a cloud, and since it is a health related data, so any kind of manipulation or any kind of attack is not permissible, because based on that data only we are taking some sort of decision. Now, if some intruder or attacker will access the data and he will manipulate, then maybe the doctor will have some sort of wrong kind of medication to that particular patient. So that could lead to a loss of a life of a particular person. So that's why the data privacy and security is one of upcoming challenge of IoT in a healthcare. Of course, when we talk about the wearable device, then we need to also think about the hardware security of that wearable device. So like in our case that we are using a glucometer, and through glucometer we are storing the data at a cloud. Now, whatever the data which is being stored at a cloud, whether it is coming from a genuine glucometer or not, that is also one of the problem that we need to address. So for that, the hardware security issue of the wearable device is important. Data integrity, cloud security, of course, access control is very important. That means whatever the data is available at the cloud, whom should we allow to access those data? So that is also a very critical point that we need to manage. Power management is very important, because in an IoT, we want that the sensor should capture the data from our body throughout the day, 24/7. But variable device or portable device are battery operated. So of course, the battery life is very important. So for that, we need to think about some better power management system so that this kind of sensor would allow us to capture the data throughout the day. Interoperability in IoT is also one of the critical challenge. Okay, because here it is a heterogeneous network where so many devices are being connected. Now, one device is from one company, another device is from another company, and there has to be some protocol where all the manufacturer has to become on a common platform so that this data sharing among the device is seamlessly possible. So at the end, I want to conclude with that IoT technology would play a very crucial role along with the AI in your healthcare domain. Through an intelligent algorithm and machine learning, definitely data analysis will be possible, through which we can migrate with the traditional healthcare to a smart healthcare. Of course, for the smart healthcare adaptation in our day-to-day practice is still a challenge, because there are some open issues which we need to address, like a privacy, hardware security of the device, your power management. So all these issues need to be addressed before we adopt such kind of IoT based technology in our healthcare domain. So with this, I am ending up over my question. I would be more than happy to take up some queries.
Thank you, sir. Thank you for this wonderful session. So dear participants, you can ask your question in the chat section and Q&A section, or you can also raise your hand so that we can
Maybe I can
unmute
also
you and you can interact with the expert. So there is one question in the chat section from a participant named Aditi Biswas Das. So
Okay.
she is asking that how IoT can be used for early stage 1 detection and diagnosis of cancerous or tumor cell growth in the body.
Okay, so basically with the IoT, see, means ultimately a sensor, variable sensor are there. So sensor will capture the data. Okay, capture the data. Now it could be a case for the cancer patient. Okay, so maybe there will be some biosensor which is there inside the body, or maybe through some sort of variable sensor through which you can actually find out the some of the critical parameter of your body. So through this sensor you can capture the data. Okay, but this data processing through AI algorithm is not possible at the edge. That means where you are capturing the data, these sensors are very small. Okay, we do not want to wear a sensor which is of bigger size. Okay, so we can't expect that that processor is being placed at the sensor end. But of course, whatever the data is being captured through some sort of IoT technology, it could be available at a server where the analysis is being done, and the decision will be taken, and the decision will be sent to taking some sort of action at the sensor end itself. Okay, so for the cancer, diabetes, for the diabetes, as I already worked that for the glucose measurement, it is very important, because for the chronic disease like a diabetes, continuous monitoring is very important. Like a cancer, if you are diagnosis at the early stage, then reversal is very easy. Okay, through taking some sort of medicine, you can reverse that situation. But if you came to know at later stage, where you are already in a critical stage, then it would be very difficult to manage it. So in this way, the IoT is very important, where sensor can capture the data throughout the day. Okay, you do not have to actually change your routine life. If watch is there, which can capture, because Apple has already announced that whatever the watch they have developed, through which you can measure your blood glucose. Now, if that watch is giving me a blood glucose, then you will just think about that how good for you that you can get the blood glucose value throughout the day. Even means if it is a non-diabetic person, then also he would like to love to wear that particular watch and just observe his blood glucose value. Okay, so this way it could be very useful. I hope I have able to give you the correct answer.
Yes, sir. Thank you. Thank you for your query, for solving the query. So next is another participant, Miss Sheetal ma'am. So she has messaged privately. So she says that, sir, can you just elaborate how IoT helps in COVID-19 detection?
In
COVID-19 detection.
COVID-19 detection. Okay. So IoT is actually definitely helping. In fact, means one of the slide that I won't put it, but one of the device that in a group we worked at for a easy band. Okay. So that means there will be a one variable band. Okay. That you need to wear at your arm. So this actually concept we have proposed in May of 2020. So in early days, at that time, the tracing of the COVID patient is very crucial. Okay, so if you remember that, if at that time, early time of the COVID, if there is a one COVID patient, then you need to actually identify that in last 48 hours, the people who come in a close contact of that COVID patient, what are those people? Okay, so for that, one of the solution that we have developed is an easy band. So you need to wear a band. On that band there will be three indications: red, green and yellow. Now red indication is suggesting you are COVID infected. Okay, if you are a COVID infected, then there is no harm. That means you can actually move around. The only thing is the people surrounding you have to keep the social distancing from that particular person. Now if it is a red indication, then it is a COVID infected patient. If green indication, then it is a healthy patient. But now it could be a case that you could be in a close contact of a COVID infected patient. So at that time, that band will automatically convert its light signal from a green to orange. Now with that, you will come to an indication that you are in a close contact of the COVID-19 patient. Now you need to be in a isolation now. Okay. Apart from that, this device, whatever is easy band, it is capturing a device ID of your surrounding location within 13 feet. So what happened, that contact tracing is very easy. Suppose that today I am being infected by COVID, and this variable band is already having a device ID of a other variable band. So this device ID of a easy band is unique for each individual, like a mobile phone. Okay? So वो unique ID से I can trace out that particular person, and that person has to go for an isolation. Okay, so this kind of IoT solution we have already developed, where that data which is being stored, and that data is being supplied to a server after every 30 minutes. Okay, 30 minutes के बाद वो डेटा आपका सर्वर पे ट्रांसफर होगा, और वहां पे आप देख सकते हो कि आपका आज के मोमेंट में कितने लोग आपके क्लोज कॉन्टेक्ट में आए हैं, if it is required, if you are being detected as a COVID-19 patient. So such kind of solutions are there. Okay, so in a COVID-19 means IoT, as I said, that mobile based application, over there it is a IoT technology. आपने मोबाइल से कैप्चर इमेज की, वो इमेज फिर सर्वर पे जाती है, उससे आपकी न्यूट्रिशन की वैल्यू पता चलती है और फिर वो आपको बताता है कि आपको क्या खाना है क्या नहीं खाना, ठीक है. सो दिस काइंड ऑफ सोल्यूशन could be easily adapted where IoT could be useful. Even IoT could be useful for the food supply chain management, which is very important during this COVID-19 time, because we are actually thinking about that we need to eat a product which will boost our immunity. But whenever you view any food product, then it is very difficult to identify this particular food product is healthy or not. Okay, पैक फूड में तो एक्सपायरी डेट आती है, लेकिन आप जब वेजिटेबल और फ्रूट्स खरीदते हो, एट दैट टाइम यू डोंट नो व्हाट इज द एक्सपायरी डेट. So there are some sort of technology which is already in a early stage of the development, through which you can actually use a NIR spectroscopy, through which you can incident a light on a food item, and at the receiver end you can actually measure the light intensity. Now, according to the whatever the virus which is being present inside your food item, the detector will detect that whether this particular food item is in a good shape or not. So actually, when we are eating something, at that time we perceive that we want to boost our immunity, but we don't know that whether this particular food is good enough that it will boost our immunity. So such kind of solutions are already there and research are going on, and IoT has played a very huge role in developing such kind of technology in last few years. I hope I have given you answer.
Okay, thank you, sir. So there are some of the participants who are raising their hands. Sir, with your permission, shall we unmute them,
Yes,
sir?
yes, ma'am. Please.
Yeah. One participant, Sabyasachi Paridhar. So I'm unmuting you, Sabyasachi Paridhar.
Good morning, sir. Am I audible, sir?
Yes. You are audible.
So first of all, it was a very nice presentation and a lot of information I learned. Sir, one query is about that you show that video. You use that sensor that is middle of the hand, and
Yes.
when you are moving moving your hand, the robot arm that will start to work. So my query is about that
Yes.
how we can distinguish that sensor current, because the sensor is that is present middle of the hand. So the current is coming out from the middle of the hand. So how can you distinguish that current so that arm will start to work?
Okay. So basically what you need to do, that you need to identify the muscles at your body part. Okay. So आपके body part में muscles है, वो muscles पे आपको EMG signal को capture, means you need to capture the EMG signal through a muscles. Okay. Now when you perform a different activity, ठीक है, then whatever the motor unit action potential at the muscles which are available, it is different. It is something like that when I am holding the mobile phone, then whatever the action potential which are available at my muscles is a different when I am having my open hand. Okay, this potential is being different. Okay, so what we have done, that we have actually done a study that if I am doing this particular activity, then what amount of the action potential which is being generated at this particular muscle. So this study we have done on a healthy patient, and through which we have actually classified that if this action potential is being generated for this particular muscles, then actually the user intention is this particular activity. So what we have done, that through which that muscles potential, we have generated some command. That command we have supplied to a robotic arm. Now robotic arm is also having some sort of actuator. Okay, that actually helps the movement of the different finger movement. So we are sending the command to that particular actuator, and through which that robotic arm activity is being performed.
Okay.
So if you want, then maybe we can talk means more details. There are few papers are there on which we have worked on. Maybe if you want, then means we can discuss it more in detail. Okay.
Definitely.
I can
Sir.
share my paper with you where all the details are there. Even I am sharing my email ID to all of you so that you can connect with me at any point of time. But possibly we can have a next question, ma'am, if possible.
Yeah, sure. So next
Because
question.
I think we are running out of time. Maybe next speaker is already in a queue. Sorry for that. But maybe we can take.
Yeah, actually the next session is from 12:30. There was break from 12 to 12:30.
Okay.
So we will
possibly
take
I'm
one.
hitting time for the participant. There is no issue if they are being connected. I'm happy to answer all the queries.
Yeah. One. We will take one last query, sir, from RC Ramola, sir. So I'm unmuting him. Yeah.
Okay.
Yeah, RC Ramola, sir.
Very good afternoon, sir. My question is because of the like sensor which we are using or wearables we are using. Generally, I wanted to know what is the procedure for standardization, particularly in IoT, and very particular about when we are monitoring the health of a patient. Is there any international standards in IoT? And particularly when we are using network like 5G or 4G LTE, so whether we have to use a very critical network or I wanted to know about these things.
Okay. So just to answer to your query, if I am understand it correctly, you want to know about that IoT platform that from the device, from the sensor, how it is being
Yes.
connected with the server for that.
Particularly, sir, standardization, because we don't know that the variable we are using, whether it will be applicable for the, particularly in the patient conditions where you have to give the prescription. So
Okay.
decision is the
So
prescriptions,
yes.
how we maintain the standard in the
Yes. So for the medical device, the most popular standard which are available is a FDA. Okay. That is a Food and Drug Delivery Administration, which is the head office at the USA. They are providing a standard, and that is almost being accepted throughout the country. Okay.
Okay,
So
sir.
that is a main authority. That means there are some protocol they have defined, there are some rules, regulation, and you need to pass all of them. Then you can come up with some sort of variable device in the market. In India, we have a CDSCO. So I'm not sure that it is Central Drug and some standardization. Okay. So CDSCO and ICMR, these are the two authority actually which providing some Indian product a standard so that they can be useful for a medical application. So there are some standard and benchmark are available, and you need to pass all those benchmark. Then your device is available. It is not something like that if I've developed something and I can use it for a patient. Okay. So basically you need to pass those standard, then you are allowed to sell this particular product in the market.
Okay, sir. Okay. Thank you. Thank you, sir.
Okay.
So thank you, sir. Thank you for solving all the queries, and thank you also for this wonderful session. So on behalf of the principal coordinator of this program, Professor Ratnajit Bhattacharjee, sir, from IIT Guwahati, and the CI of E&ICT Academy IIT Jaipur, Professor Vinit Sahula, sir, I thank you, sir, for accepting our invitation and coming on board and sharing your knowledge with us. Thank you.
Okay.
Thank you so much for connecting.
Thank you all of you. Have a nice day ahead. Thank you.
Thank you, sir. So dear participants, the next session will start from 12:30 onwards. So we will have a short 15 minutes of break and we will start by 12:30. So we request you all not to disconnect from your system. Please remain connected and we will resume by 12:30. Thank you all. Hello, Rishab sir.
Yeah, hello, ma'am.
Yeah. So you are audible, sir. So we are making you the presenter now.
Okay, okay, ma'am. Fine.
Yeah, now you're the presenter, sir. You can once share your screen and have it explained before the
Okay,
session.
okay, ma'am. I'm sharing. Okay. So my screen is visible, I guess, right now.
Yes, it is absolutely visible. So we will start by 12:30.
Okay, okay.
Okay, thank you. So welcome all participants. So welcome you all in this second session of day 7 of this 2-week long joint online faculty development program on Internet of Things and applications in smart systems. So this session will be hands-on session number 6, which will be conducted by our next expert, Mr. Rishab Kumar from IoT Academy. So before we start this session, we will have a brief introduction of our next speaker. So Mr. Rishab is having more than 6 years industry experience and currently working with Uniconverge Technologies Private Limited, Noida, as a senior system engineer for various projects like wireless node and IoT gateways for IIoT, data aggregation and monitoring systems, LoRaWAN, predictive maintenance, etc. Rishab has major interest in electronic design and embedded software development, along with end-to-end integration of the IoT systems. So with this short introduction, I would like to welcome you, sir, in this platform. Over to you.
Okay, thank you, ma'am. So good afternoon, everyone. So today, welcome to our hands-on session. Today we will doing hands-on on IoT-based contactless body temperature monitoring system. So, am I audible, ma'am? And my screen is visible? Can you confirm?
Yes, sir. Yeah, you're clearly audible and screen is also visible.
Okay, okay, fine. Thank you. So, our today's hands-on is like IoT-based contactless body temperature monitoring solution. So, in this solution, like we will be measuring a body temperature and monitoring as well as capturing the image of that particular person. So, it has various use cases, like it can be used in a lot of places for attendance and for confirming, like in this COVID situation where everyone we have to measure the temperature of every visitor and the person in various facilities. So these are the steps here. So first we will be using here Raspberry Pi. So we will be installing an OS on Raspberry Pi and enabling camera, SSH, VNC and I2C to connect and control for the RPI. And we will be using MLX 90614 sensor. It's a infrared detection sensor, temperature sensor, and it's a digital sensor with a have a output of I2C. It outputs data on I2C. Then we will be using PyCam for our camera to capture the image. Then we will be using SMTP services for sending an email of that particular image captured with a temperature data. And then I will be explaining the code. So here are the few tools required. The first one is Putty for doing SSH. With this, we can log in into the terminal of the Raspberry Pi and we can execute our commands. The another one is a VNC viewer because most of us will be not having the monitor or the keyboard connected to our RPI. So we will be doing a VNC session into it and getting the display on our laptop. So we can control and do our things using our laptop only. But they both are completely optional if you have a like a monitor, keyboard and mouse connected to RPA. So first step is a Raspberry Pi OS installation. For this, we will be needing RPI 3 and RPI 4. Anyone can work. The RPI 3 will also work. RPI 4 can also work. The steps are same for all the both of the board, and even on RPI 2 it is same. So any RPI 2, 3, 4, it is this experiment is relevant. Then we need a micro SD card, at least 16 GB or 32 GB. High speed one is preferable, like class 10 or more than that, because it has a good read and write speed. So the performance will be much faster. Then we need a memory card reader or adapter. Okay, so I think the OS installation done in day 2 of the program, someone is saying, but anyway, I'll just brief you once and then we can move on to another part. So we need again a power supply, a Raspberry Pi camera module, the sensor MLX 90614, higher temperature sensor. So first we need to go to the Raspberry Pi website to get the Raspberry Pi OS installer. We can do in two ways. First one, this is the most simplest way, where we have the good stable internet connection. We download this utility, we put our SD card and we can just flash it. The another one is like we can download the OS first, then we have some another third-party tool like Windows 32 Disk Imager or Balena Etcher, something like that. These are ISO which just loads the file on the SD card or takes the ISO image. And both can work if they have both the advantages and disadvantages. So I will be currently using this method because it's one of the most simplest method. So like we on this website, if we click here, you can see in the software section, here you can download for Windows and download for Mac OS as well. So I already have the downloaded copy. So I can just show you, like I can, if I type go in Raspberry Pi Imager. So here you see, this is my Raspberry Pi software. And we have to install, this is the steps for installation. So first we need to choose the OS which we want to install. So we'll be using a RPI OS 32-bit. So we just choose it from default. Then we need to insert the memory card in the USB port or on the SD card itself. Reader, if our laptop have a SD card and port and a SD card adapter, we can do that. Then we have to choose that particular storage. And here I will show you how to install a Raspberry Pi OS in a completely headless manner. Like if you don't have a monitor or a keyboard or anything that you can attach or a Ethernet connection to get the IP of that particular device out and you can work. So I will show how to connect it to Wi-Fi using this only and how to enable SSH and everything. So this will be helpful already if you have done this, but I think this will be something which can add value to start in the completely headless manner. So I will just go there and choose a OS. Then I will just mount the card. And here, if you can see, let me just make it bigger. And here is a small settings button. You need to click on it. And when you click, here you see a dialog box. Let me make it a little bigger. I think this is the maximum it can go. So you will get this option for this session only. It will, like if you want to enable the SSH, so we can SSH into our machine or Raspberry Pi. So we can, from here we can enable the SSH, and we need to set up a password for this Raspberry Pi. We can set the password from here also. So I just set it. I just set the password Raspberry, and if I also wanted to configure the Wi-Fi, so once I click on the Wi-Fi, you can see it's already connected to my laptop's network and it taken the password from there only. So can anybody from the audience can tell that I'm going with the right speed or I need to slow a little? Are you able to catch what I'm just covered? Or if you have any doubt, you can just write in the chat so I can repeat that also.
So dear participants, in case if you want any, you want to give any suggestion regarding the ongoing session, you can let us know in the chat box. So we will do accordingly. Thank you.
Thanks. So here we just configure it the Wi-Fi also. It takes off from the, if we want to connect to another, we can just put our SSID and the password. We can also set the time zone, like what is the time zone. It automatically detects from the computer that what is the time zone and what's the layout, and we will hit save. Then what it does, it automatically generates the SSH file and WPA config files, which configures the network as well as the SSH on the first boot itself. So then I will just need to click on write, and it will pop me a message like it is gone. It will erase, all the things will be erased. I have to click on yes, and now it is connecting to internet and writing on this SD card. So it will take some time. Let me show you the process. Like first, Here the process, and first it will write, then it will verify the SD card. So it will take around like 5 minutes to 10 minutes to sometime more, depending on the internet speed, because it is downloading from the server in real time. So it will take time. So if you have a good internet connection, it will be faster, and depending on the SD card also. If we have a faster SD card, it will be like much faster process. If we have a slower SD card, it can be a little slower. So this is the first step. And here is the step if we don't use this, like if you don't use this utility, for example, if we don't have a very stable internet connection, and if we want to use some other utility, and if we want to now do this and now use our RPI in a headless manner where we don't need to connect to a monitor or a keyboard or a mouse. So this is how we can do. We have to connect the memory card, and then we have to go in the memory card option. Memory card itself, it is like a boot drive, and there we want to create a file called wpa-supplicant.conf. We have to create a file wpa-supplicant. Then we have to open the file in a Word or any text editor, which of our choice we can do. Like here we opened in the notepad, and here like this you can just put these configurations, like you can put the interfaces, network, and scan SSID, and you can put the SSID and password of the particular your Wi-Fi, and it will work. And for SSH, like if you want to do SSH, we just need to create a SSH file, and the SSH will be enabled by default. So now you see the verifying is done. And now the SD card is kind of ready for using, and now it is ready, and I can remove the SD card. Okay, so I just remove the SD card from my computer. Let me show you in this board. Let me go in this. This is the file. So when you just boot it, you have this SD card will show as a boot drive, and here are the files which are there. And if we haven't done with this utility, we have to manually create the two files. Now I can just put in our Raspberry Pi. And after that, we will be using a IP scanner tool. Either we can do it with our router settings also, if we have access to our router settings. If we have to access our router, we can just simply log in our router and check for the IP what it have. But if we don't have access to our router, we can use this program like IP scanners. Like there are various IP scanners, advanced IP scanner, this one Agri IP scanner, and we can just do it from here. And then we will be needing Putty to do a SSH session to enable VNC, but because we already enabled it from there. So this is the hardware I'm using. We have designed a board. I think this video is visible to all of you. This is our Raspberry Pi development kit. We made it for like college student to work and prototype. So here is the Raspberry Pi. And here is a small breadboard area where you can like prototype stuff, and here is a proper microbus adapter where you can connect all the microbus accessories and connector boards and all the thing. And we made a small power array, and this is powered from a proper USB B type connector. So we don't need to worry about our micro USB and other connector thing. So this is the board we designed for like education purposes to have. But you have any standard Raspberry Pi is just good enough to work. So is it visible? Or if you have any doubt regarding this board, you can just write in the chat box. I can answer some of the queries. Like some of the participant can write that they are at least they are able to see the board or sensor. Okay, how I will do it in the full screen. Okay. Let me stop sharing, then I think I can do it in the full screen. Now is it showing in the full screen manner?
Yes, sir. We can see the board in the full screen. Yeah.
Okay. So I just for the time being, so here we designed this board for like ease of use in the colleges and the universities. But for now, RPI is enough. So here, this is a carrier board where RPI 3 and 4 both can be mounted, and you can order in two options, either as RPI 3 or 4, and it has all the GPIOs labeled like what GPIO is what, and it has a proper power connector of a USB B type, so we don't need to worry about the micro USB cables, and we can connect all the accessories on the top of the RPI because it has a standard headers and there, but also it has this microbus expansion adapter. Like microbus is an expansion platform where you can buy various kind of microbus adapters, and you can just put it there and interface it with a Raspberry Pi. So like if we want to interface some kind of a sensor, some kind of a application devices, we can just use the microbus. They have a lot of them in their portfolio, so we can use the standard one. Like we have we also make these expansion, like we have an expansion for LoRa and Wi-Fi BLE already is there, but we have expansion for LoRaWAN, RS485 interfaces and other. And here is our MLX sensor. Here you can see we are connected with the breadboard, and it is connected to the US this board RPI. We're using the I2C communication. So this is our board, and I can show you. I just for this I have connected a screen, but today we in this experiment we will be using in a completely headless manner. Like I have a screen here. You can see if I can bring. I have connected my Raspberry Pi to a screen, but even if we don't have a screen, we can just work on it. Okay, so back to our presentation. So now I have to connect my SD card. So I'm connecting the SD card to my board, and then I will be doing straight VNC because I already configured this card for VNC SSH application. I can just simply SSH in and I will do a VNC. So now I have connected our newly formatted SD card into our Raspberry Pi. Then now it is initializing. I can show again with your camera because I have the monitor. Like here is our device and here is this RPI, sorry, monitor. And now the RPI is booting. The first boot takes time because it has to adjust in every for the screen resolution and all the thing it has to detect. So now it's the it will come up. So first boot takes a time. Generally, normally it just boots within a 1 minute, not a second. Within 1 minute it boots up, but the first boot can take up to like 2 minutes, 3 minutes or so.
So if the participants want to interact in the session, they can raise their hands. We will unmute you and you can interact in the session. Thank you.
Okay, ma'am. So now it is booting. It is taking some time and it will boot up. Now you can see the cursor on the screen and here we have the desktop. And now it is showing because we already enabled the SSH. It is showing the SSH is enabled as a default. Set OK and it will automatically connect to network because I already put the Wi-Fi credentials there. So it will automatically connect to my network. So now it is connecting to our network and then I have to get its, I will be using Putty. So Putty is a similar tool. If we have to know the IP of this particular Raspberry Pi. And also one thing, like we have to, because I connected with a full HD monitor. So what happens if we connect to a bigger screen? It's a small tip for you. So the processing will be slow. So we have to lower our screen resolution because if we will be doing some work and if we set to the maximum resolution of this Raspberry Pi, then the performance will be little laggier. So we have to just lower the resolution sometimes. But if we are using with VNC, we don't need to do anything. It is just fine. So now I will scan for the IP. Like I will be using an advanced IP scanner, but you can use this, which is mentioned in the PPT as well. Both will work. They are the same thing. Like first we need to just okay, so let me scan the IP. Actually, I'm using this on my computer. I'm using the 5 gigahertz one, and on the RPI it's 2 gigahertz. So I have to configure it once again. So like I have to scan the whole network to get the IP. So here I have to search for Raspberry Pi. That in the name it will come as a Raspberry Pi. Now check. It's taking some time to connect to my network. We stop and do it once again, I guess. I just start scanning again at the network. From this IP scanner, sometimes you get a little more time, but if you have access to your router setting, it will be very easy. Like do it one more time, or otherwise I can directly use my screen to get the IP. So it is taking some time, but I know my what's our RPI IP is, so I will go straight in the putty This is the IP of I have to here to show you a warning, but we have because we are already we know this client and IP, and we have to click on the yes. So now I have to log in. I have to put my username and password. So username is this, password. And now I'm connected to my Raspberry Pi via SSH login using putty. And then we have to configure the VNC because most of us will not have the monitor with us. So we have to configure the VNC for this experiment. So we can get the whole desktop experience on our laptop also. And for the VNC, we have to install a real VNC viewer because this RPI comes with the native support for the real VNC. So I will show you how to download it also. And so now we have to go in this Raspberry Pi config window. So let me go in the putty. This is my screen. If you have any questions or problem, you can ask me if any there is any doubt in the steps which I'm uh, gone through. You can just simply raise the hand and ma'am can unmute you. So you can ask your question. And I think this is visible from my side. The putty screen is visible, and you can, I think, read the fonts. Like although all the commands is already will be shared and already in the PPT itself. Like you here you can see the command is already there. So I have to go in this Raspberry Pi configuration. So we have to go in this interface and we have to just enable the VNC. From here, we can also enable all the other things, but I can like here from here, you can enable the camera that we will be needing. We will be needing VNC, we will be needing I2C. From here, you can also enable, and you can also enable from this uh, actually the VNC. So I will only use the VNC and show you how to use it graphically via the VNC viewer. We can all like we have to hit yes. And now it is enabled. Then we have to just finish. And here you can reboot it, or in our case, it will not. We will not reboot it because it will take some time. And now we will be needing a real VNC viewer. So I will show how we can get this. This is the real VNC viewer. It's a VNC client. So we can just you can search for real VNC viewer. This is a VNC client, and you can download simply it for Windows, and you have to install this one, real VNC. So you have to download this real VNC client because VNC server is already running on the RPI. So you can just click on download and you can download it from because I already have this downloaded and running in my system. I will give you a 5 minutes time to download it on your PC, and on the same time, if you have any questions, you can ask me. You can raise your hand or write in the chat box. So I can
Hello.
answer your query.
Yeah. Hello, Rishabh. So there is one question in the Q&A section
Yeah.
from a participant named Anand Kumar. So he is asking how to connect Raspberry Pi to computer.
Okay, that's what I'm showing you for. If you this is the whole idea of this experiment is to how to start a Raspberry Pi in a headless manner to operate it only with your computer. So we will be the tools are like if we only need to access the command line interface of the Raspberry Pi, then this tool putty is enough. If we know the IP of our Raspberry Pi, then this putty SSH is far more enough, and we can do a lot of things from this only. But if we need to look at our desktop or GUI, we will be using this VNC viewer. So to get a screen. I hope I answered your query. If you have more doubt, you can just ask me.
Yeah, he's saying okay, sir.
Okay, yeah, ma'am, I can see. So is there any other person who have similar questions or queries regarding this OS installation or any other query? You can post in Q&A also. I think you can post in the Q&A section as well. There is no more questions. Yes. So how many have, I think you have a Raspberry Pi with you, because we are doing hands-on session, like how many people have your Raspberry Pi with them, or they have earlier worked with Raspberry Pi? Okay, so now I will move uh, to how to connect it to VNC. So let me show you. Like I have this VNC viewer already with me, and we just need to type it. Let me close it again, and I will show you how it works. Okay, close it again. Let me close it, and I have to run the VNC viewer. And here I have to enter the IP. Like I have to enter 92.8.18.205. This is my IP for the Raspberry Pi. I have to enter it, and because I already connected it to, because earlier I also connected with the other Raspberry Pi with the same IP, so it is good. So I just need to enter the password again. So here you get this authentication box, and here we need to enter the username and the password of the Raspberry Pi, which we set on using our this Raspberry Pi disk imager. We have to put it there, but for the default it's Raspberry. The default password is Raspberry and default username is Pi. And if I click, and now it is connected. And you can see my Raspberry Pi screen is just, it comes on my laptop. This is the exact Raspberry Pi screen, and it is showing here, and here is our VNC client. You can see there's a small logo, and it's connected to my network, and here you can see this screen. So now we can use it from here. And if I show you with my camera, like it's the same screen which is there on my monitor also. So I think I have covered. And here are the few things that we need to set, but we already set in this like our disk imaging, so we can skip this part. And now we have to configure the Raspberry Pi for our I2C, and now already VNC is done, SSH is done. We have to only configure it for I2C and camera also. But camera option is not shown here because the camera on the latest version of the Raspberry Pi 3B and 4, it's a legacy feature, so they don't show here. So for that, we need to go in this again, the Raspberry Pi config in the command line to enable it. Because on the earlier version, the Raspberry Pi, they have a support for the onboard Raspberry Pi camera, but now they have moved to more of a USB webcam approach. So from the next revisions, it will be not supported, but for current experiment, it is supported. And we can still use the legacy features. So let me go and do, like, I will go to the VNC. One thing I can do is like if I change, I have to remove it. So let me. Now here you see this is SSH, VNC, and I2C. Because our sensor is I2C based, we have to enable I2C. And I just enable I2C, I just clicked OK. And now the I2C is enabled. Here the screen is a little different, but it is, and we have to just update the packages because it changed the package. So we have to update the package. So we just need, it is not visible. And now it is visible. So I just need to write the command. And it will update the packages. It is taking some time because the package is closed, so it will download some package and it will update it. Okay. So this is our first step to configure our Raspberry Pi OS and all. Now I will move to the our second step, that what interfacing the sensor. So let me give you that we will be using a MLX 90614 with the Raspberry Pi. This is the sensors, how it look like. It has a V in, ground, SCL and HDA pin, and it works with all the both 5 volt and 3.3 volt as well. The logic level is a 3.3 volt. So and here it is how it works. Like it's the infrared thermometer designed for contactless temperature sensing as a 16-bit ADC to have a higher accuracy. But in real life, for the accuracy, we have to really go dig deeper and calibrate it. So to get the very good sensing resolution, although it claims that for the best known resolution is 0.2 degrees Celsius for the sensor, and it is factory calibrated. So we don't need to calibrate it manually, but for digitally, we need to calibrate it. Here is the working principle, like it transforms infrared radiation from a body and from any body and object into electrical signal, and then after convert it into a some value, and then after it gives over, we can read it off over the our I2C lines, like I2C interface we will be using. And here is the block diagram. Here you can see the sensor 8110 is the sensor, and now these all the uh, boxes for this ADC and DSPs for processing and all the thing that it need to process. And after that, there is a PWM generator which generates the PWM for our data line. And here are the some of the application, like for it is for the for lower application, like it can be used for like where we cannot reach, like some for like some factory condition where we need to contactless monitor the temperature, and the other things like here listed. And also the majorly here we seen the contactless temperature monitoring is always used in the COVID situation where everybody is walking out. In the if we go somewhere, they have to contactless measure the temperature. So they are in this application we have, this is also used, and for medical application it is also used, and also in the industrial applications where we don't know what the temperature is. So we just first measure it with the contactless one, then we think that it is safe to open or safe to work, then only we can do our working. And now the update is done. You can see it takes some time, but now update is done. So we will be using Python for this experiment. So we'll be downloading a Python library for this sensor. And here is the link for this Python library. So I just need to copy that link to my browser. And we have to make sure that we download this 0.03 version. But because for the 0.04 version, there is some changes. So the exact same code will not run. There will be some modifications that they have done. So for now, we are using 0.03. I have to copy the link address for this because I don't need to download it on my computer. I need to download it on the Raspberry Pi. Like I can also download it from their browser, but it will be a very slow process. Like I have to copy the link address. Make it little bigger. Okay, so I just need to wget. This is a command, and I have to paste this file path. So it will download the file. Like here you can shown in the step, like I just copied and I have to paste in the Raspberry Pi terminal. So now it is downloaded. So we need to check. And here you see it is downloaded it's a tar file. Now we need to extract this file. You can see that it is downloaded and we have to extract the file. Is there any questions from the participants? So let me know. Or if you have also trouble in following, I can repeat the steps again. If you want me to repeat any of the step, I can repeat it again and explain it again. So I just need to run this command. I have to extract the trunk, so I will be extracting here. I have to extract this tar file, hit enter, and now it is here. Let confirm. And here is the files. You can see now they are extracted. Let go in this file explorer and we can see. Here is our tar file and here is the folder where we extracted. So here it is. Now we have to install Python setup tools for this. So here is the command for it. Like should I app get, okay, sorry, this is the wrong one. Should I app get Python setup tools? So I have to install. Paste it here. And now it is downloading. We have to hit yes to download. So just enter yes. And now it is downloading. No, so it will be downloaded on the Raspberry Pi memory itself because I downloaded here in the memory. Let me show you. Native resolution is my native resolution little high, so it is little lag here. But here you can see I downloaded here only. I use the wget command to download. We can also use the browser to download also, but it will be slow. That's why I done with this wget command terminal. And we downloaded it on the SD card itself. Like here you can see the file I downloaded here and extracted it here. So now it is downloaded. And installed also. And then we need to install the I2C tools because we want to get the address of the sensor because yet we don't know the address of a particular I2C sensor because I2Cs have an address. So we have to install this tool. We can also get this from our data sheet, but for this time I will be using this tool. So now the I2C tools is like installed. The PPT you can see. Then we have to go in the directory and install the library which we downloaded. So we have to change the directory to this and we have to just install this file. That is a Python file we have to install. The command is here. And now it is installed. The PyMLX 906.4 is installed. Okay, so now we can shut it down, Raspberry Pi, and connect the wiring, but we already connected, so this is step is there. But the best practice is to shut down the RPI and then connect the wires most of the time. Like even if we done something like wrong wiring or anything, then it will not damage our Raspberry Pi. So here is the pin map for this Raspberry Pi, and it is also printed on our board also. So we have printed this whole GPIO on our board, which correspond to which pin. And here is the sensor pin out. First one is V in, second is ground, and third one is SCL, and fourth is HDA. And here is the wiring diagram. And then after wiring, we will power it up. So let me show you how we wired up. So here, if I will show you, this is our sensor, which is connected on the breadboard and connected via this male to female wire to this header. Is it visible? And here is the Raspberry Pi and here is the sensor. So now we move forward. So here is the connection. The VCC is pin 2, ground is pin 6 on Raspberry Pi. SDA is pin 3 and SCL is pin 4. Now we need to power on Raspberry Pi. So Raspberry Pi is already powered on. And then we have to go in the directory, and then we have to detect the I2C address, like on which I2C address it is there. So we are already there. Let me run this command, that is I2C tool detect. So here you say it is started with all the addresses, like and here our sensor address is 5A. So we got the sensor address we will be using in the code. to test the sensor for this. And what it does, it scans all the address from starting from 00 to all the way up to 77. It scans like continually, it scans the address of that particular I2C device, and when it gets the response, it will just print the address of that particular I2C device. So in our case, the sensor address is 5A. So any questions till now? If you have any question, you can write on the Q&A and chat, or you can raise hand so ma'am can unmute and you can just ask your question. So now we got the address. We have to go in the folder and we have to now write our first code. So our first code will be to test that sensor is working and giving a correct data. So simply we will write the MLX, this is the name we given, and we will write a simple code. And this code will be shared with you also. So let me just go in the folder and just create a new file. .py. I have to make a Python file. I have to click a py Python file. And here is the simple code. We will be writing. Let me open in. If you double click it, it will open in the editor. Raspberry Pi come with a default editor for Python. And from here we can simply paste like this. And here you see we have written SM bus 2 because our I2C is also known as the SM bus, system management bus, because it is also used on the processors to monitor all the system peripherals, because what happens, all the system peripherals have the I2C, like power supply, other interfaces have the I2C connection, and then CPU can simply query that what are the status of all the IOs and peripheral. So it does it using by the SM bus, this I2C communication. So that's why here it is written I2C bus. And if we click on build and click on compile, now it compiled successfully. And what we are doing, we are taking, we have put this 5A, the address here, sensor address, we have put the bus and we have put the address, and we are just printing the ambient temperature. Like what is the ambient temperature and what is the object temperature. So let me run it. Now you see the ambient and object temperature it is printing. So from our side, the sensor is ready. Let me show you again if I put my hand up close. The readings are little are not calibrated, so that's why it's giving like this. So you can see the reading. So till now, any questions or doubts regarding this? If you have any questions or doubt, you can ask. Or is there any step you want me to repeat that you are not able to catch up? So I can repeat that step again also. But everything is a very detailedly mentioned in the PPT. So PPT will be shared and you will be able to do this experiment by following the PPT steps. So now we will move on to our mail and camera setup, because now sensor is already set up. Now the second part is complete. We will move on to the third part. That is Raspberry Pi camera interfacing. So we have to interface the camera. So we will be again going in the Raspberry Pi config and in the interface options, and then we have to select the legacy camera. And we have to enable the camera itself. The camera is connected via the MIPI CSI interface. MIPI CSI is an interface for MIPI is an interface for multimedia devices for connecting displays and camera. So MIPI DSI is for display interfaces and MIPI CSI is for camera interfaces. So today we will be using a MIPI CSI based camera, and we plugged into Raspberry Pi. So let me show you in the command. Here in the interface options, I have to enable the legacy camera, and then it will ask for reboot. And it gives you a warning like it will be not supported in the further development, but on the older OSs it will be still supported. And we hit enter. And then finish. Then it will ask us to reboot it now. So we have to reboot our Raspberry Pi. So from here you hit enter and it will reboot, and now we will lose the connection. Well, now it is rebooted, so connection. So let me show you how we connected the camera. Stop sharing my screen and start the video. So this is a Raspberry Pi camera which we are using, and it is connected to this port here via the MIPI CSI interface. This is the MIPI CSI interface for camera, and this is the camera module we are using. So now our Raspberry Pi come up again. It rebooted. And now it is booted again, and then I again have to I have to now check that if camera is working or not. So for now, I will just click a small simple image to check whether the camera is working or not. Fine. So here is a command for Raspberry camera. It's a Raspberry still, and we will be saving it on the desktop. And the file name will be image.jpg. And then I'll just paste it here. And let me hold the camera. And now it displays the camera overlay on the screen and it captures a image. And you can see the image is saved on the desktop because I already pointed it to desktop. And if I open the image, it will be imaged like this. Here you can see the image of my colleague. So image is captured. So now we have tested that we have a camera is working for us. So is there any questions till now? You can please ask, and then we'll move to our SMTP mail and then to the final product experiment. So I will give you 5 minutes to ask the questions in the chat or this Q&A section, and also you can raise hand to answer. So you can be unmuted to ask your question. Then I will move to next topic. Yes, it supports for Raspberry Pi 4B. This will work also because it has a already same camera connector also. But USB webcam can also work. If you don't have the camera and you have a USB webcam can also work. Is there any other question regarding OS installation, sensors, or camera interface on Raspberry Pi? So in 2 minutes, I will be starting SMTP. Okay, so now we will move to SMTP. I think if there are no more questions. So we will set up the SMTP email. So SMTP, I think everybody know. Okay, there. Okay, difference between SMTP and SMTP is a mail protocol. From here we can send an email, where HTTP is the web protocol. From it is for the web pages and the web request, and SMTP is dedicatedly for emails. If we want to send an email, then it will be governed by the SMTP protocol. So here you can see SMTP. It is governed, managed by IETF, and it is dedicated a protocol for mails only. But the problem is here, like if we want to send data from Raspberry Pi and any other devices like Arduino, Raspberry Pi ESP, any of the embedded devices, and using some kind of script either in Python, C, or any other language, then the Google doesn't simply allow, because it consider it as a less secure app and it can affect the security. So for this, we will for temporarily we will be disabling the security of our mails which we are going to use to send the email to another. So senders email should have the functionality to support less secure app. The receiver doesn't need to have that, but the senders need to have. In the Google also, if we have our own SMTP server, like we have our own mail server, then we don't need this step. By default, they will be supporting. So for doing this, you just need to go in your Google accounts and under the security tab, you have to stop the two-step verification. Now you have to turn off this two-step verification. Two-step authentication, you have to turn it off. Then because what happens, it when this device is want to connect, then there will be a pop-up and it device won't able to connect. So every time it will connect, it will ask for the two-step verification, but our device only will have the passwords, so it cannot do a two-step verification. So we have to just remove the two-step verification from there. So like we have to turn off the two-step verification, and we have to enable the less secure app access. So we already done with our test setup, this one, and we have to allow less secure apps, and we have to turn it on. So is there any questions on this? Now we have to install the SMTP. So here is the command for SMTP installation. Simply just it is small again. Simply paste SMTP. Now we will be installing. We have to hit enter. Sorry, yes, Y and then hit enter to continue our installation. Now it is complete. SMTP is installed. And then we have to install the mail utilities. For sending mail, we need some mail utilities like to attach the attachment image and to write the body, write the subject line. We need this mail util. So I will install it also here. I just click it there and hit enter to install. Again, yes, and continue. And after that, we have to set up the SMTP configuration because we want to enter the sender's email and password and also the domain name. And so we have to open in the editor because we can also use our file explorer to do that, but because it don't give us permission to access the root of the file, so we have to go with the terminal also. So here's the simple command to open this SMTP configuration and enter our configurations. We simply copy it and we paste it here, and it will open the file in the nano editor where we can edit it. Like here, the file is open, and now I have to add our configuration. So here is our configuration. Here you see the mail hub because we are using Gmail. So mail hub is our Gmail, and we have to our email address as your user authentication user. We have to put our email address, we have to put our password, and we have to start the TLS. So let me, I have written in already saved this. See. I just copy it from here. I just simply paste it here, and then I will just enter my email address which I'm using for this experiment and the pass. I have created a dummy email address for this experiment. I'll name as a test bot. Then we have to save it. Then we have to close it. So now we put our configurations in. Like here are the stuff mentioned. Our test setup is now email is configured. So we have configured the email address. Camera, we already configured it, and sensor we already configured. So now we have to run our application, write our application code. So is there any questions or query you can ask? Then I will move to our coding part. Okay, so now we will move to our coding part. Okay, so now we will go in the code explanation. So I will write a code for this. Like for writing code, we again have to go in this file. We have to write in the directory where we already write in our text setup. Just open there and creating a new file, like create temperature underscore monitor .py Python file I have to create, and we need to edit it. We have this code written. I copied it from here and now I'm pasting it. Just paste. And here is our code. We are importing our GPIOs, camera and time, as well as SMTP libraries. Now I just saved it. You have to click on the save and it will save. And now you see the compilation is successful. So let me show you if I can make it. So what I'm doing, I'm just using GPIOs, this Raspberry Pi camera time. I'm importing SMTP. I'm also importing and I'm using SM bus for our I2C communication. Then here I think it is not visible. I can show in the PPT if possible. Okay, now I zoomed in and you can see I just put the from message, from address. This is the same email ID that we just configured in our SMTP configurations, and we put on the address that from this address you have to send. And here I put my email address to which they send the data, and I'm using the mail utilities and from to, and for the subject line we are reaching temperature value exceeded alert. And now we are sending the image. Please find the attached email is the body. And now then we will click a image, capture a image, and we will save the image with our timestamp, and then we will send it. And here is the our continuous code while work, and we are running like this every time we are checking and sleeping it. Every hundreds of a millisecond it is sleeping. And we have set the camera brightness to 55 and auto white balance to auto mode, rotation to 0. These are the camera attributes. You can for more, if you want to learn about the camera, you can simply go to PyCam camera. Sorry, it's PI camera. Sorry, not PY. You can go on the PI camera documentation, and here you will get all the details like how to use a camera, getting started, every detail. You will see that how to get started with camera. There is every bit of detail, all the APIs, how to all the commands, how you can use it. There is also all the things are there, like how to capture a video, how to capture a simple image, all are there. So it's a PyCam, it's a Python library. So here I'm using this one. And then we can simply hit run. So it will start running the project and it will continuously print the data. It is printing data also. So we can run it from here also, we can run it from terminal. So we will be running from terminal. So let's go to terminal. Yeah, we have to redirect to the directory. Then we have to run the code. And now you see it is just showing the data continuously. And if I put my hand there, like now it just detected because we already put if it is for 34 and above, it just said because the camera is still not calibrated. So it is not sorry, camera. I'm just complete. I'm sorry, not camera. The sensor is not calibrated, so it won't be as accurate as it should be. But we can calibrate it using our software. In software, we can calibrate it with our other reference device. Let's say we have a proper calibrated temperature sensor, and with respect to that, we can calibrate this one also. And now, if I go to my mail and check if is there, I just need refresh. Sometimes it takes little time to upload. Now you see the temperature value is exceeded and it just clicks the image of my colleague. Here is the image sample. With the email saying here is our subject. This is a temperature value exceeded alert, what we put in the code. And here is a please find the attachment is the body. And now it attached the image as known here you can see. And also if I go, let's I just close this. If I go in our file explorer again, and now you're showing it continuously sending data. Here you see the image is captured and saved with the timestamp. That what we are doing. That on 25th Feb 2020, it saved this time with the timestamp. And if I open the image, this is the same image which it send over the SMTP over the mail. So is there any question? What I will do, like I just stop sharing the screen and I will use my camera to show you how we are doing the whole setup. Like let me stop sharing my screen.
Hello.
Yes, sir. Sorry, yes, ma'am.
Yeah.
Hello.
So, sir, we request you to please share the code of the program.
Yeah, ma'am. All the resources will be shared. I will share the PPT and the codes also, along with the
Okay,
instructions.
sir.
There is
Okay,
something
sir. Thank you.
without the capture to any digital media store or digital media or storage. Yeah, it is already storing on this particular file location. But yes, we can with the help of some libraries and code, we can just. It is not simply that we can only save in some okay storage DB. Actually, that I think it is missed. Storage DB. I got it. So yes, we can store in the DB. Like if we use our some kind of storage file system,
if we use our FAT-FS, let's say we implemented a FAT-FS, we can store it in file system also, and we can also store this image in our database also. Like we have a remote database, we can also store the image on the remote database. That can be done. We just need to simply modify. No, actually pops up if you are talking about MQTT, particularly as a publish subscribe model. So on MQTT protocol, we cannot send a image data because it only takes the binary data. Okay, streaming, yes, streaming it can be done. We can stream using some of the UDP. We can use the UDP protocols to stream, and we can stream the data also from here. For streaming, we have to use the other camera APIs, like what I shown you. For streaming, we have to stream it via the other APIs, like which you can see in this web page. For streaming, there is other, but yes, we can stream data. But the frame rates will be little lower. On the Raspberry Pi 3, the frame rates can be easily, if you are not doing any kind of, it can be 15 to 20 frame, max of 30 frames. But on a Raspberry Pi 4, it will be more higher and it have a better quality. So now I will click on stop the screen sharing, and I will show you the exact hardware. So stop screen sharing. Restart again. So here you can see this. This is our board itself, and here is camera. And he pointed it on himself, and he will put his hand on the sensor, like he's just putting hands on. And here you see on the screen, it is showing his face. Camera is capturing his face, and it is now it will be sending a mail to my ID. And now also, if you can see here the image is captured. You can see this is the image. It captured the camera. And we will receive this image also. See, we received this image. Here also, sorry, you cannot see. See you on my screen. I think my screen is okay. My screen is there. And here you can see I got the mail with the same image. I got this mail from the same image. Here you can see this is a mail. So is there any questions regarding the setup or the experiment? Like let me explain you the code. I will share the code. This is like how we implemented this SMTP library. Sometimes if you there can be a version different. If you have the different version installed, you can simply go in their particular wiki page and you will get that how to use this libraries. But if let's say later on the future they have some additional, they added some features, and if this code is not working, you can just simply search for the alternate APIs which are used and it will work. Like here you see form address, we put like dashboard and to address any of the receiver's address. We can also send you the emails from to one of you participants if you like. We have to change in the code and we can do that also if anyone. And here is for the mail, how we are sending a mail, like we are attaching the image and then we are giving the SMTP address, then we are giving the login credential, and then it is sending a mail, then we are stopping. And this is how we are capturing the image. We are also capturing the image with the date, date as well as timestamp, and we are also starting a preview. Like it is when the camera is taking an image, it displays the image on the screen also. It just uses it on the screen. It shows you a image, then it captures the image, then it stop the preview, and then it call the send mail function, sorry, to send the mail. And here is the camera setup. Like camera is, we are using pi camera, rotation is 0, auto white balance is auto again, and brightness is 55. We can, and at last we are using while loop, so continuously the code is running. Like in a VNC, if I go, you can see the code is currently running. It's keep on running every time. And when I put my hand there, it's just captures a image and it's so. But actually what happens, the image which is used, it uses the hardware HDMI to output this image. So we cannot see it on the VNC, but we can see on the camera, sorry, the monitor, but we cannot see on the VNC. So that's why you haven't got a screen overlay with this, but on our monitor, we are able to see the screen. Sorry, we are able to see the camera image, that is it. And once it sends the image, then again it keeps on reading the data. Okay, so it is just connected via the HDMI. Let me start my video and show you. And this is the HDMI cable. It is connected to my monitor directly, and it is giving me the output here via this HDMI cable I connected. I think it is visible to you. Okay. Okay, is there any other questions? So from this, the experiment is live completed. So if you have any questions or any doubts, you can ask.
Yeah, dear participants, so you can ask your queries in the chat box and the Q&A section, or else you can also raise your hand so that we can unmute you from our end and you can interact in the session. Thank you.
Okay, so the idea of a whole for tomorrow labs, you will be needing a Node MCU board along with the like a temperature humidity sensor DHT11 and like this soil moisture sensor. So basically, there are a couple of use cases for this one. Like apart from detecting only the human, like in this COVID situation, we all doing this attendance system, virtual attendance, and capturing the image on runtime. But it also have the industrial applications as well. Let's say we have some asset and we put a camera there, and also we put a temperature sensor there also. And if there is something goes wrong or something beyond the range what we said, and then it can immediately capture image and send it to you. Like if I have a, let's say I have a motor, which is a very common thing in the industry. So the motor is placed there. Let's say due to some reason, the motor stopped turning, there is something wrong with the wiring, or there's simply overheating or fire. Let's say there is a short circuit completely and there is a fire. So what it does, it's sense the temperature. No, the temperature is gone beyond that optimum level, and it will just click the picture. No, so this is the picture of your asset which you are monitoring, and here is what happens. So you can look at that. Oh, is there any short circuit, or is there any debris or anything stuck on the something, or so it get overheated. Even it's not only to the stills, we can have a video stream and we can get a good view. So any other questions or any other doubts, please ask. Yes, this skin I'm not getting, but yes, it can sense the any object, like it can sense the data of the skin because it's already used in this our contactless thermometers also. So any kind of object it can sense because it's only dependent on the infrared. So any object which can emit an infrared, it can sense.
So dear participant, in case if you want to interact, you can raise your hands. So I guess all the queries of the attendees are being answered. So thank you, sir. Thank you, Rishab, sir, for this wonderful presentation in day 7 of this program. So we request all the participants to please note down 2 things. The attendance of day 6, that is yesterday, has been updated in the drive. So we request all the participants to have a look into their attendance every day. Okay, so that if you have any queries regarding attendance, let us know in the Telegram group so that we can sort it out at that moment only. Because later it would be very difficult for tracking all the 10 days attendance. Okay, so that's a request from our end. And also we request the participants to please note down the spellings and the spelling of their name and also their institutes so that these 2 details are perfectly fine for the certificate preparation. So that's it from our end. Thank you, sir. Thank you, Rishab, sir, for joining today. So on behalf of the principal coordinator of this program, Professor Ratnaji Bhattacharya, sir, I thank you, sir, for joining. I guess tomorrow also you will be presenting hands-on session number 4,
yeah,
right?
Yeah, ma'am. Tomorrow, thanks, ma'am. Tomorrow I will be also presenting a session.
Okay. Okay. Thank you. So we will be meeting you tomorrow at 12:30 then. Thank you, sir.
Yeah. Oh, yes, ma'am. Okay. Okay.
Yeah.
Bye, everyone.
Okay.
I think now the session is over.
Yes, sir. Absolutely. So dear participants, thank you. Thank you for joining today and making this day 7 of the program so successful. So we request all the participants to please disconnect from their end. The meeting link will be deactivated in another 2 minutes. Thank you. Thank you all.
Okay. Bye, everyone.
Bye, sir. So tomorrow we will be meeting at 10 o'clock, everyone. So we request all the participants to please be active from 10 onwards. We will be starting the session sharply by 10. The meeting link will be remaining the same. Also, the Google Drive is updated. So you can have a look on that. Today's materials will be uploaded shortly. Thank you. Thank you all. Thank you all for coming today and making this program. Day 7 of this program so successful. Thank you. Thank you all.